That's wrong. Wrong, man. Wrong.
Boop, 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 boop. All right.
Good morning.
Good morning. Good morning. Hyvää huomenta. You can always trust the army to like, you guys go automatic. Huomenta. It's 2 minutes past 9. Let's begin. We have a lot of stuff to go through today. There are a lot of good speakers today. Tomorrow we have some not so good, but still, it's gonna be exciting 2 days. Welcome to Iglooconf. Martin, please, do your demo. We wanna see it tomorrow. So, Finland Azure user group. To whom is this a new thing, organization, Finland Azure user group? Is everybody familiar with us? Couple of new ones. Excellent. Basically what we do is we do non-profit cloud computing meetups. This is the biggest one we do yearly. This has been at the end of January, probably next year again, end of January. And then we have PolarConf, which is usually
October-ish.
And then we have these meetups, at least for a year, every quarter in Helsinki, and they are evening stuff. And then we have some other events like Global Azure Bootcamp and Global Integration Bootcamp and Global DevOps Bootcamp, and we attend those. So this kind of stuff. We have 1,500 members, so if you are not a member already, please join. That's basically it.
Yeah, we are also part of the broader Azure tech communities. So essentially, we get a pin on the map at Meetup. And I guess when Meetup decides to finally start billing attendees, they had some interesting trials later. We'll get that covered for us as well. So again, looking at the map, based on my geometry, we are slightly norther than those Norwegian folks. So again, literally the coolest user group as well.
All right. If you speak Finnish, English works too, I think, but you should join the MS Gurut Slack. It's set up by Jouni Heikniemi some years back. It's pretty active. It's a good channel. And then there's Ikkuna Studio podcast, other community thing. It's a Finnish podcast about Microsoft scene. It's hosted by Heikniemi and myself, and we've been doing that for 5 years now. Then there are user groups for Teams and SharePoint and SQL Server. We should add some links here, but if you Google, I'm pretty sure you can find those. And Vesa Tikkanen holds a Power BI data thing every week, like 15-minute show. If you find Vesa and ask him or look at him up in LinkedIn, you'll probably find that. So those are some of the communities that are active in Finland right now. So if you are thinking of like getting this kind of information, then feel free to reach out to these parties. A huge shout out to sponsors this year. This is like we said, this is non-profit. The ticket, we don't think it's that expensive, but the venue is not the cheapest. We want the venue to be high scale. We want the food to be good. We want you guys to have space. And therefore this event isn't that cheap to organize. And we literally could not do that without these companies. So I want to give all of them a round of applause. Futurize, Cybercom, Nordcloud, Innofactor, Microsoft, and Azure. Thank you very much. Nice clapping, guys. Talkers, speakers, look at that lineup. I think you might notice that we had a couple of persons who had to drop out due to personal reasons, but we are glad to say we were able to replace them with us good alternatives. So that's excellent. It's always sad when that happens. So we apologize if you were coming to hear a talk by one of the people who dropped out just before, but that's what happened. And otherwise, the speakers are here on your top right, and you are free to approach them. And they will probably talk about things, might relate to IT as well, but they talk to you a lot if you go say hi. You don't have to say anything more. You can just say hi and let them speak for 15 minutes solid, it will be good. Sir?
Yes, so does this work? No, let's. Well, we are here by the stage. We'll see people using some pointers, maybe physical or otherwise. We'll get to lunch later. We'll have a friendly neighborhood polar bear to show you around as well. But essentially, if you at any point want some more coffee, or if you need to take a break, a call, something like that, just head out from the doors that you came in, head to the left. There's coffee all the time available. There's some bigger snacks available sometimes throughout the day as well. There's a partner area where we have some of the partners, Futurized, Cybercom, Nordcloud. They had some swag, they had some halarimerkit, they had some stickers and whatnot. So go ahead and pay them a visit over coffee and a break as well. And as you all know, we are also streaming this beautiful thing live. So if you have colleagues who could not make it, if you have friends that you want to make jealous,
It's Friday.
Tomorrow it is. Yeah. So please share them this link, Jurly, Igloo 2020 live day 1. Please follow us in Twitter, Facebook, Finland Azure User Group, Azure UGFI, and I think we have tweeted the live stream link out as well. Or you should be able to just search with your favorite search engine, find Google, and then find from YouTube Finland Azure User Group, and we are live over there.
It's a front page of Iglooconf.
And also, yes, just go to iglooconf.fi. You can have the embedded front page link to the video as well. And we will be looking at the numbers of which countries we have the most visitors of and most and least offensive comments in there as well. And we might do some shout outs throughout the days as well.
What's interesting to share, I think, is that last year's Iglooconf 2019, the videos that were streamed then and captured then and now on YouTube, they've been watched for 2,200 hours since then. So people watch over 2,000 hours of the videos of these guys speaking here. So that's pretty exciting for us, because it means that it's not just us in the room, but it's also a wider community who gets maybe help from these guys.
Yes. Thank you. We will be spamming this throughout the day. Please don't fill this out yet. So
Give all fives.
yes, which will be unscientific, I guess. So we will also have a survey for both days. Please think about things that we can change, improve. If you have any comments on food, venue, the speakers, us, how you heard about it, anything else that you'd like to change, the timing, the venue, like
Us.
Yes, us again.
Us.
Yes. Should we put this on a cruise ship? No. Should we do this in somewhere else? Anything goes, and any requests and so forth.
Cool.
That's it. So next up, we'll hand this over to Sam, who is slowly moving. Yes. Sam van Hout is our first speaker of our Dutch-speaking day. This was not intentional, but apparently we have scheduled this in a way that the first day of Igloo 2020 is actually combined. It is actually made of only Dutch-speaking people. One Dutchman, but a ton of Flemish men. Flames. Flemen.
Flemish.
Shall I go on?
All right, let's welcome Sam on the stage.
Woo! Thank you, guys. Thanks, man. Hallo allemaal. Hello, everybody. I'm Sam van Houten, coming from Belgium, as you just learned. I'll talk about Azure Event Grid today. And while I was preparing this session, I also looked at the agenda, and what I saw is that I will cover and touch a lot of services that the other speakers will talk about for the rest of the conference. So that's nice. I'll refer quite a lot to their sessions that are coming up. So I come from Belgium, and I'm CTO at Codit. So we are based in 7 countries in Europe, and we focus on Microsoft Azure solutions for customers. We have 180 people. Now, enough about us. What I'll talk about is Azure Event Grid. I don't know how many people have used Azure Event Grid in this room. 15-ish. I hope after today that you get more enthusiastic about that service because it's really powerful. And it really fits into the whole messaging and service communication area of Microsoft Azure. So to understand where it fits and when you should use it, I think it's important to have a good clarification on the different types of events you can get. So the first thing you quite often see in applications is intents. Like, I want to create a sales order. I want to schedule a job to do something. That is myself as an application or as a person declaring that I expect something to happen, right? The other side, quite often you have facts. Think about telemetry streams and IoT and so on. These are just facts. The light is on. Temperature is 25 degrees. These are log files that get filled at web applications, right? So that's a big difference. And you could say that on the left side, you have the messages. On the right side, you have events. So event grid will be typically more used for the right side type of events, while you have other services that will be used on the left side for messaging. You have different types of events. You have discrete events, and you have series of events. So series of events, it's quite common. Think about time series of signals, of vibrations of engines and things like that, things that just come as a stream, log files, clicks on a website, these things. The other type, you have discrete events. That's something that happens at random, like a state that changed, an order that got fired, things like that. So these types of events is something that you can handle with Event Grid, especially the ones on the left. These are quite suited for that. So this is the entire messaging landscape. The good thing is that I think Eldert has a session later today that covers all these services and really talks about when to pick which. I think the 3 most common ones for these type of applications are Service Bus and Azure Queues, although I typically always want to use Service Bus queues, Event Hubs, and Event Grid. So regarding them, I think Service Bus is typically for your enterprise messaging, for messages that you really want to have delivered that are crucial to get. Think about financial data and so on. Event Hubs is more for the streams. So think about your log files, think about the telemetry and so on for your big data pipelines if you want. And then Event Grid is more if you want to do reactive programming, and that's where we will focus on. So discrete events that I just mentioned, that is happening, and you want to react with logic. And the good thing is that you will learn that you can separate someone that is publishing an event, you can separate his concerns from the people or the applications that want to handle these events. And that's an interesting concept to get scale and to move your applications further down. If the session of Eldert gives you good insights, you can even get more insights by reading this blog post from Clemens Fasters, who is like the messaging guy at Microsoft. It's something from 2 years plus ago, but it's still relevant. It talks about when to choose which messaging service for your data. So that's the positioning of everything, where Event Grid is really focused for the discrete events, you could say. All right? Now, I have 3 different common scenarios where Event Grid is being used. The first one would be, of course, serverless. You will hear that quite a lot. Serverless applications where you have the business logic that gets event-driven. So think about, and I'll show that demo, an image that gets uploaded on a website. That's an event that happens on blob storage, and you want to react against that. Without having to write or deploy containers or things like that, you want to just have some logic, very cheap. You don't want to do polling. That's really where it fits. Because one thing is important. If you think back about the days before Event Grid, we were quite commonly using queues or service bus topic subscriptions. And what we had to do, we had to write logic that was constantly polling. So that was a compute instance, quite common, that was polling on these queues. And if you have 20 messages per month, you were still having 24/7 things, running and polling. And that costs quite a bit just to handle these 20 messages per month. Of course, with functions and their bindings, I think we have a talk about functions after this, and also by Alan tomorrow. But with their bindings, of course, it got much cheaper because you don't have to spin up a virtual machine to do the polling. But with Event Grid, you just have this thing happen. It fires an event and it calls something to you, so these events get pushed to you, rather than you have to pay for yourself to do all the polling. And that's a big difference in the serverless world. What it also is quite commonly used for is for automation of operations of DevOps scenarios. So if someone creates a virtual machine, if a new resource group gets created, things that happen in the Azure resource environment, you can subscribe to these events and you can have things running. Think about notebooks for automations and so on, where you can maybe have policies that you check, like the virtual machine that gets created. Do I have the right size for that? Do I need to notify someone that he at least can check with the person that created that virtual machine if it's okay and so on? So think about billing and inventory management. And then the other one is application integration. So people that have been using Logic apps or even BizTalk past in the days, there you can really have communication between different systems, where Event Grid is also helping to push things from one application to the other. Again, it's one-to-many, you will see that. So you can have one event handled by multiple receivers. But we'll talk about that soon. One thing I also want to mention is that we believe that open source is really something that, instead of just doing talks, we also want to give back to community code and resources to use. So for that we have Arcus Azure. It's an open source thing on GitHub. You can download the NuGet packages. And I would say Tom is probably one of the most, Tom Kerkhoeven, who will present 2 times this conference. He's really adding a lot of code together with Steen at our company. And for Event Grid specifically, we have also one library. So I'll talk about that afterwards a little bit. So feel free to use it. Feel free to contribute to it as well. So we can really help this evolve with the community. Now, Azure Event Grid, that's really the service that I'll talk about. And concepts you have is, on the left side you have the event sources. On the right side you have handlers. The good thing is that this is the first conference where I was not able to fit all the sources in that left side column, because that's one of the biggest challenges for this service. Event Grid really depends on other Azure services and the other teams at Microsoft to publish and create events. So blob storage, for example, I'll show an example afterwards. But with blob storage, you can just say, if a new container gets created, I want to have an event and I want to do something with it. Same thing with resource groups and Azure subscriptions, as I mentioned, for your automation. IoT Hub is an interesting one. We have some sessions on IoT later on, where you can subscribe to a device that connects and also a device that disconnects. Because maybe you want to know that if a device disconnects, I need to notify someone. So these events get also pushed. Azure Maps is something that is interesting. Also SignalR. So people that use SignalR for front-end applications can really leverage that one. And custom events is definitely a section I'll talk about afterwards. What has been added recently is Azure Key Vault and Azure Machine Learning. So if you have Azure Machine Learning for your models that get published and so on, all these things get automatically fired as an event. So you don't have to do anything for that except for configuring things. You can say, I want to configure on my blob storage account that these and these events happen. And then it's up to you to use something on the right side to handle these events. And you can say, I have some code in functions that are just listening to these events, and as soon as an event happens, I'll handle it. At the same time, if you want to do more workflow, you can do logic apps. I think Rick has a session tomorrow on logic apps, where you have different connectors and bindings. Think about FTP protocols and so on. Well, Event Grid is a very interesting one, because you can just have a workflow started if, for example, my machine learning model has been published. You can also forward from Event Grid to other queues, like event hubs and so on. And you can have on-site things through hybrid connections and so on. So this is getting quite powerful, but still there's a lot of things that are missing, but I'll talk about that later on. So how do you typically configure it? Well, in your event publishers, in the portal, you can dive in and you can select, I want to have these and these events published. So that's an important aspect. Event Grid as such, it's like a sub-service. So you see Event Grid in all these major services like storage, like IoT Hub, and they have a section, events, and there you can configure it, okay? So on an event subscription, you can set different things, and I'll talk about that soon. So this is where I said things that I'm missing. And actually, if you see the link at the bottom, there's another MVP. I think he was here last year, Sean Feldman from Canada, who has set up a GitHub repository where you can create issues. If you feel that there's some event that you would love a Microsoft product team to build, you can create it there. Because the power of Event Grid really depends on that one. So what I'm missing in the types of scenarios, because I mostly work with IoT and data projects, is in Azure Databricks, in the structured streaming, but I'll talk about that later. Azure Functions can listen on events, but cannot spit out events in the bindings. IoT Hub is now being covered, so that's an old one. So IoT telemetry events, if you have that coming in, you can handle them. Stream Analytics, I'll show that. In Stream Analytics, you can output to functions and so on, but you cannot output to Event Grid, which is something I miss. Also in Azure Monitor, there's things missing, and of course with Cosmos DB, okay? So, of course, use that GitHub thing, because we really want to leverage it towards Microsoft also to put a little bit of pressure from a community and customers. So, 5 concepts are important to understand, and they are quite easy if you're familiar with events as a whole. So events is what has happened with a declaration of things inside. You have the publisher, which is spitting out these events. He's raising that. So that publisher can be something, a standard Microsoft service, or your own application. And I'll show that afterwards. The topics, so a topic is where an event gets published to. So the only thing that you have to do if you publish an event is know where to send it to the topic. You don't have to know what will happen with the event. You don't have to care if someone will handle that event. It's perfectly fine to spit out events and no one is listening to that. It just costs a little bit, but at least you're flexible for the future, right? So topics is the only thing that you have to know as a publisher. At the same time, if you subscribe, as a subscriber, the only thing that you have to know is the topic. You don't have to know the source application. So that's the decoupling happens over that topic. So in subscription is where you receive and how do you handle these events. And then we have, Event Grid is really a very powerful service. If you would have to build this yourself, good luck with that. So Microsoft luckily did it for us. So it's an always available service with almost real-time delivery. What is important is that it has at least once delivery. So again, think about handling duplicate messages, right? It can happen that the same event gets delivered twice. And it's platform agnostic. So you can handle events that are being spit out from Azure. You can handle them on-prem. You can handle them in your Amazon, whatever platform you have. At the other side, you can also use other applications and publish events into Azure. So it's really the only thing that you have to be able to speak is HTTP REST, which is, of course, quite commonly known. Also important, there's a maximum size, message size of 64K, which should be more than enough, in my opinion. The way to handle events quite commonly is, okay, Inject as much as possible and relevant information, but don't use it as a file or as a message transformation protocol, because again, it could cost. However, there's a message size up to 1 megabyte. I believe it's still in production, and that means it's in preview, and that means it's not backed by SLA. So if you now send messages up till 64, you're backed by the SLA. If you go above that threshold, you're not. You're in the preview mode. Okay. This is how an event looks like. I'll not talk about the details. So this is a standard schema with a topic where you send it to, the subject. So that could typically be the device ID of your IoT hub. This could be your machine learning model link and so on. It's an event type. So in this case, this is a blob created. So you can use that to handle it. It's a blob created. You can have a blob deleted, a directory created, and so on. Every event has a unique ID and an event time. When did the event happen? And then you have the payload, the actual data, and that's an open structure that people can use to inject their data. So the data contract for this blob event will be different from the one that you have for a telemetry event of IoT Hub. So that's where you have the flexibility. And also if you publish your own event, this is also what you can use. This is a Microsoft proprietary schema. You can use cloud events at the same time. So cloud events is an open standard that is being adopted by multiple companies. So this is also supported, and you can actually indicate the type of event that you want to receive. Is it cloud events versus event grid specific? And I would, if you start with a new application, I would say, why not go with cloud events, because you're even more cross-platform. And the structure itself is quite similar. So the data is where the actual body is, and then you have all these other metadata properties. Performance-wise, this is huge. 10,000 events per second per region, 10 million, sorry. 100 million subscriptions per region, and they aim for a 50 milliseconds publisher latency. So I think that's quite huge. What is important is also that they have failover, because they are pushing to you. And imagine that you have something that is spitting out a lot of events. As the event handler, you have to make sure that you can handle these events coming in, because if you, for example, have an HTTP webhook that you expose that gets called by event grid, you have to make sure that that application, that logic is capable to handle that. And what is also important is that they have retries. So if something fails at your application, there's a new wave coming, right? And they, of course, have some logic internally to not say, if there's 1,000 failing now, we will have all the 1,000 fired at the exact same time. They play and fiddle a little bit with that, but it's still, there's another wave coming, right? So they have also a backup interval. So I think it's 10 seconds, 30 seconds, up to 1 hour. And they retry for 24 hours, right? I'll talk about that in this slide, because it also means, and look at this is cheap. 60 cents for 1 million operations. So if you have 10 million events, it will cost you $6. An operation is, of course, these events, these matches and delivery attempts and so on, and you get 100,000 free operations per month. What is important, and I laid out 2 things, is first of all, it's per chunk of 64. So if you use that those messages of 1 megabyte, it means if you have a 640K, you will pay 10 messages, right? And that's why I believe if you're not sure that all these events that you publish, that they will be handled by someone, I believe it's better to publish something that has a reference to the actual bigger file so that people can go and fetch it afterwards if they handle it. It will be cheaper to do so, and also regarding performance, I think it's better. Another one is the delivery attempts. They also cost. So I just showed the backoff interval. So you can easily have for one message and your webhook is down, or you have even deleted it, but you forgot to remove your event grid subscription, and you have that on an Azure blob storage where all the telemetry is coming in. All of that gets retried and so on, and you pay every single attempt. So this is something you have to be carefully monitoring, right? Now, I think I talked about publishing events, how Microsoft Azure and their services are publishing events. Of course, what you want to do now is do something with these events. You want to write logic, you want to have your processes being kicked off, and that's by consuming these events. So the first one I'll talk about is webhooks. So a webhook is very simple. It's an HTTP endpoint that gets called with a payload. It's typically a post. And what is important is you cannot have every web endpoint listed there. There has to be a validation. Think about a website from your competitor that has a big announcement, for example, and you say, oh, I want to have something denial of service attacked. What you could do, oh, I will list that website as a subscriber to events, and I'll just have something writing all these blob storage things, so that Azure Event Grid is pushing and hammering it. Azure Event Grid will be much more powerful than most of the regular websites, for example. So you cannot just do that. The only thing that you can do for a webhook to subscribe is to have a validation handshake, and I'll talk about that. What is also important, and I feel that there's something missing, is that it's quite limited in security. So the way to secure your webhook is only by passing in something through a query string, like question mark key equals secret key. So you cannot have a secret key in a header or something configured. That's something that I'm missing, and of course OAuth is definitely not in place there. So how does the validation work? If you create, the first time you create and start up an event subscription for a webhook, you will get this message, which is in the event type. It says subscription validation event. And that subscription validation event gets a key. That key, in this case, starts with 512, the validation code. And you can just, you have to send back the validation response with that key. So that's the handshake that you have to do. If that happens, as from that moment, they will start sending these events to your webhook. Okay? So the way I will demonstrate this is with request bin. People use and know request bin, I hope. If not, this is a free tip. So with request bin, you can create a request bin. I will not do the private because then you have to log in. And this is now just an endpoint. Of course, people can now start sending to this. Let's not do that. But this web endpoint is something that I will use, and that you can just start spitting events, and you can really monitor what happens. So it's like an inspector in the cloud. So what I will do here is now I will set up in my portal a very basic event handler that just sends all these messages to the cloud. And I will do that with blob storage because it's very easy to demonstrate. So I have somewhere, let's mute. Here I have a storage account. And as you can see, and I'll zoom in the storage account, this is where Event Grid is hosted, in events. That's where I can have my events configured. So it's not that I have to go to Event Grid as a separate tab. Event Grid is embedded in all these services that support it. So with the events, what I can do, in the portal I can very easily say I will create a new event subscription. So I just give it a name, let's call it Igloo demo. Here you specify the type of event. So you want to have your cloud event, the open standard, or you want to have the event grid schema. Let's pick the cloud event. You can also use your custom schema. If you really want to do that, and if maybe the receiving application is something that you cannot control or change, that's how you can fiddle with the request that you will send. So here it links with the storage account, and this is where I can specify the type of events I will enable. So by default, I have every blob that gets created, every blob that gets deleted, and these are more the data lake events, like directories and blob renamed and so on. That's specific for data lake. So I will have these events listed, and then I have to specify these endpoint details, where I specify, and let's zoom in again, you have an Azure function. So that's the session of Martin and Alan. You have a webhook, which I will show now. You have storage queues, which I don't believe you should use. You have event hubs. Hybrid connections is to send to something on-prem. So you can have an endpoint in your own data center or on your own device that is actually registered in the cloud, and that's how you would call into that without opening and drilling holes in the firewall. And then you have service bus queues and topics. I think Eldert will talk about those. So let's pick webhooks in this case. And I have to just specify the endpoint. So that's where I will copy the ID from there, the endpoint. And that's also where I would pass in my secret key with a question mark, with the query string. So as soon as I click create, which I do now, there should be, if internet goes well, there should be something pushed here, and that's that validation handshake that I talked about. And it's still waiting for the first request. And that's, of course, what you don't want to see happening. So it needs to be validated before the subscription is created. That's at least what it shows. Let's do an F5. Let's forget about that one then. This was the most simple demo you could imagine. So what happens is Microsoft would now push that message into this endpoint, and I would get, if I go back to the slides, I would get the validation URL, which is an HTTPS endpoint, and the only thing I have to do is I have to do a get, and actually I pass that validation code in that get, and as soon as that happens, the handshake is done and created. So this is probably just taking a while. Let's forget about the validation here. What I also want to show is how can you do filtering. Because of course, as soon as you send out events as an application or as Microsoft, you get a lot of events with metadata information. What you want to do as an application, as a receiving application, is probably you want to do some filtering. Maybe you get events for all the blobs in that storage account, while you might be only interested in the ones that are coming from that specific container. Or you're interested in all the events coming from that specific IoT device. So what you can do is you can have subject filtering. So if you think back about how the schema was looking like, it always contained a subject, and the subject refers to the actual originating publisher. Like in this case, you would get the file name, the blob file name. And you could say, oh, the subject has to end with, in this case, for example, .jpeg. And you would have a handler that only handles the JPEGs. Maybe you have another one to do image transformation on the PNGs and so on. You can also say, oh, I want to have the subject filter to do start with, because there you have the container, for example. So that's how you can do very simple subject filtering. What they have added is advanced filtering. So with advanced filters, you can have much more filters that are looking into the data. So if you have in the data payload structure, you have data that you want to use to subscribe to, that's where you do it, just by using the dot notation, so JSON structure following. That's how you can specify very easily filters that say, okay, this is, for example, data.message.type. And here I can specify equals string in and so on. So this is like a very simple rules engine if you want. So that's the advanced filtering that you can do. And then you have the additional filters, messages that, or features that I talked about, that are more around how to handle the retries and so on. So the dead lettering is something that you might be familiar with if you come from storage and queuing and things like that. So what you can do, I can say if the delivery attempts have failed and have been exhausted, I still want to have that event saved, and that's what you do here. And the only way to save it is by storing it into a storage subscription. Of course, you can, on that storage subscription, again have event handlers and nicely propagate things. Then you have the retry policies, as I said. So this is standard policy that I explained, you can fiddle with that. You can say an event has a time to live, like the event after the time to live, it will be dead lettered. And then you have the subscription expiration, which is, like for demo purposes, quite easy to do, where you say, okay, I make sure that the subscription, deletes. But at the same time, I can see scenarios, again in serverless applications, where you create an event handler, and you say, oh, this event handler is only, I want to monitor something for a flight, for example. I will have this event handler automatically expire after the flight has taken off, for example, right? That's the way that you can play with that. And you can also do batching and AAD authentication, which is a new one that I didn't look into. Okay? So that's a basic overview of how to create event subscriptions. And let's forget about this one. So that's the validation. So I talked about filtering in two ways. So this is on the right side, and it's probably not well readable, but the advanced filters, they are also part of the ARM templates that you want to deploy, and that's the structure they have. So you have an operator type, a key, and a value. Exception handling, as I mentioned, and as the demo that I have to just show a very simple lightweight application, I have a Finnish menu translation. So let's go to the thing first. It's a talk like a Dutch day, but I don't know how I have to pronounce this. I can only imagine that it's a lot, because it's a long name, so I would have a lot to eat. So this is, of course, the Finnish menu that I don't know what I would order, except for number 5.
It's 1 meal.
It's 1 meal. Thanks for that. It's a salad. So what I have is I have actually 3 storage containers, just for demo purposes. I would not build a real live application like this, just to get the gist. So if I upload this menu into the menu input, what happens? I have event grid that registers to the event, the blob created. And then I have a handler, which is just a webhook. So it's an API that does that validation handshake, and then says, I will use, on the right side, you see cognitive services to do the OCR. So OCR is character recognition from the image. And the output of the OCR would be text, still the finished text. And it stores the finished text into the menu OCR. And there again, I have a blob trigger that goes to the event grid. And again, I have a different subscription using the filters to say, oh, if it's in that directory, I want to have the other operation called in my API. And that is just calling another cognitive service, which does the translation. So it translates, I believe, into English. And then the stored menu, the translated menu, will be stored in the other directory. So that's how it goes in this setup. You have at the bottom the 2 subscriptions that you can see, but let's show it live at work. So we have the storage container here, so menu input. So I will upload the file. Finish menu. And the only thing I have to do is upload, and all the rest happens now automatically. So let's do a refresh on the OCR. You can see that there's a new message received at 44. And then we have the translated output, where I do the refresh, and now we can see, if I download this one, maybe I can just open it in storage. You can see how well the translation goes. It's not perfect, definitely, but I might go for the cold smoked herring caviar, which is quite okay, I guess. So that's the way things work. Let's go back to the actual events in the portal now. So if I go to the storage overview, as you can see, I have all these events at the bottom, right? For demo purposes and so on. What is the one that I want to show here? It's these 3, the event, menu new, menu create, and so on. So on the OCR, you can see very simple, how many events get handled. What happened, I think the last time I executed this was when I was, I think it was in Belgium, doing this talk, and I didn't touch it, and it still just works, and I pay peanuts, nothing for this, because it's all serverless, and it only happens whenever I drop that file, so I don't have to pay for Event Grid just because I use it. I only have to pay it when I would use more than 100,000 menu translations, and I don't see a business case in that yet. And here you can see that I'm calling this API at the bottom. So the storage account with that, and I can then see the filters. And here I have used the subject filters. Subject begins with this, and here I'm pointing to that specific directory. All right? Going to the code very quickly. This is where I have that translator happening. So it's the API controller, very normal, and it's 2 years old. I think not even in .NET Core. But I had created this specific subscription validator that does all the handshake validations. All of that is available in Arcus. So for that, let's go here. So this is the Arcus GitHub that you can just get access to. If you click on Event Grid, then security, I guess. You should be able to see here the Event Grid subscription validator. So we moved everything away from that ugly code that I write, and then we have people that do much more decent code, and that's a result of this. So what they did, they actually created an action filter attribute that they hook into the HTTP pipeline. And then we say, okay, if the action context contains the AEG, so all the headers that Azure Event Grid is sending start with AEG, Azure Event Grid. So if the event type equals subscription validation, then what I will do, I will handle the subscription validation event. And that's what happens here. So I'm reading the event and so on. I do some basic validation checks. And if I get the validation code, what I do is I return a new message with the status OK, and that contains that validation coding. So this is all done for you. The only thing that you have to do is use this attribute on your HTTP controller, on your API controller. You tag it with this attribute, and everything happens for you. So you don't have to care about that. It's just adding this with the NuGet package, and all goes automatically. All right? Now, we talked about how to handle things, and you can do it with logic apps and so on. I'll talk about that soon. You can also publish events. And to publish events from your own application, the only thing that you have to know again is where is the topic. So you have to know a topic endpoint, and of course, you have to know a secret key, an authorization code. So you create a topic in the portal, and then you can copy the authorization keys from the access keys. Again, on a topic, you can see perfectly how many events have been published and how many events have been handled with Azure monitoring and so on. So you can subscribe to that. You can really use that also as metrics for you. So to publish topics, you have, of course, the SaaS key and the SaaS token possibilities for authentication. And what is also being added is event domains, and that's a special one. So think about an enterprise that has events to publish, but actually it wants to know that I'm publishing events from my application, but this specific event should only be accessible by my customer A, and the other one should only be accessible by customer B. So you want to have some security, but you don't want to create a specific topic for all the different specific publishing topic for all your tenants. What you can do here is you can use event grid domains. So from a publishing point of view, you publish to event grid domain. The only thing, and that's what I don't like here, the only thing you have to do is you have to specify to which topic at the receiving side it will happen. Because if you look at the right side, maybe I should zoom in again. So you publish to this domain-specific endpoint, and as from there, because I have specified in my publishing event that it has to end up at topic 5, for example, it will be routed to the Redmond construction in this case. What I would love to see, though, is that I can just have it published to an event grid domain, and that I can specify the routing logic on the domain that, again, as a publisher, I don't want to know where the message has to end to. And that's what I don't like. So what I would hope is that I can do routing inside the domain by creating the rules there. Or another option could be if you could have an event grid topic subscribing to another topic, so that you have something like a forward to. And if you have another event grid topic that is actually being capable to handle events, you can have one incoming event on your publishing topic that gets distributed to multiple other events, and you could have other people registering on all of their own topics. I would love to see that, rather than this approach where, as a publisher, you have to specify it has to end up to that topic, because I cannot do one-to-many. Okay? But still, it's a nice approach. What is also interesting is that on the receiving side, on the subscription side, so your customers, if you want, your tenants, they can subscribe to this topic, and they can use Azure Active Directory of their own tenant. So they can use that as authentication mechanism to get access. So this is more intended for enterprise scenarios, but I hope that is coming. What you also have is domain scope subscriptions. And again, you have to get access to that. But you can say, I want to have a subscription on all these events, regardless of which topic they will go into. It's like for auditing purposes or for your own application internal logic. Okay? Now, DR is definitely something that is crucial in this setup. So they have different things for metadata versus the actual data. What is important is that all the information of the health endpoints, and that's what you want to use if you want to do manual DR and manual actions, all that information is available on an HTTP endpoint API.health on your topic. So you can use that into your logic to do failovering, to do scaling and things like that. All right? What I also wanted to show is how you can use Event Grid in your integration testing scenarios. And again, I'm using shamelessly the content from Tom here, who created the blog post of that. But what he did is he actually creates a topic, an Event Grid topic, and if you want to see how these publishing of events happen, you want to have that back in your test. So in your test, you can say, I submit an event, and I want to have something subscribing to that event and do my validation check there, like you're testing your asserts. And that's what happens here. So behind the scenes, and you can just deploy a template for that, behind the scenes, we're from that topic having a subscriber that is a function, and that puts it on a queue, so a service bus queue, and your test will create a subscription. So at the start of the test, it will automatically create a subscription on the topic. And again, session of Eldert will give more details on that, I think, on topics and subscriptions, to say, I want to listen to all the messages that come from my test. And you have that subscription created. It pulls the event. As soon as the validation happens, it also creates, or deletes, the subscription. So the topic itself remains clear. And that's how you can quite easily do real integration testing, rather than stubbing everything out with pure unit tests. Okay? Now, the other one that has been added, and this will definitely link to the session of Martin tomorrow, because he doesn't speak Dutch, is Azure IoT Edge. So Azure IoT Edge is the service that you can run in the field for your IoT solutions, and it comes with different modules. So the modules that you have are actually containers, and Martin will talk and show all of that, also how you can create your custom modules. But these modules, they run locally, so you can build your custom module to read the output from this projector, for example. At the same time, you can use modules from Microsoft. So Microsoft, for example, has stream analytics that you can run in the cloud, but you can also create stream analytics jobs that you execute on the edge, so close to your devices, for example. Also blob storage. You can have a blob storage in the cloud, but you have a blob storage service on the edge. So all these things ship as containers to your edge device. Now what is important is that for Azure Event Grid itself, they also have created a container. And that container can be running on your local device. Now, this allows you, for IoT Edge, to have Event Grid working as a publisher and as a receiver on the edge. And one thing that I have some problems with is, okay, when to use Azure Event Grid on the edge to do the routing between all these modules versus when would I use the standard routing mechanisms that Martin will definitely talk about. Because the standard routing between one module and another module on IoT Edge, they go over that, let's call it the local storage, but it's the Edge hub. It's like a mini IoT hub on your device, and it's more asynchronous queuing, where with Event Grid, you can do push from one module to the other, okay? The difference that I see for scenarios and when I can use it is if you want to do device-to-device communication. Because you can have Event Grid on 2 devices, and you can communicate to each other. You can subscribe to events from another device. Think about one device that handles something in the production line at the beginning, and it wants to send an event like, whoa, I think I have some bad quality created, so maybe you want to handle that and you want to know it further down. That could be a way to notify each other. Because that's the nice thing. Event Grid on the edge, it's really symmetric, so if you want to use it and if you want to send events and publish events on the edge, you just use the same logic, the same DLLs, the same HTTP endpoints and so on. But you can have a mix between module-to-module communication, and that's where I still would use the IoT Edge standard logic. You can use edge device to edge device, and you can also use it to do cloud to edge device. So you can subscribe with your local IoT Edge device on events that happen in the cloud again, using the same patterns. And you can use your edge device to publish events into a topic that is in the cloud as well. So this makes it all quite complex for your IoT scenarios. But what I also see is that since they have now Azure Event Grid in a container, in a Docker container, and they deliver it still in preview, by the way, they deliver it on IoT Edge. What I see is that the fact that they have it in a container, I see and I hope that they will also ship it regardless of IoT Edge, that you can just use Event Grid like they did with API management recently with Arc. So you can use API management locally if you can have Event Grid locally. And I think the vision of the engineering teams of Logic Apps was also, I think 2 years ago on Integrate, they said, we also want to have that running everywhere. So if that is also coming, you could see scenarios where you have things on-prem that are still relevant today for mission-critical production scenarios. You can have the same services running there that then integrate into the cloud and back and forth without having to fall back on legacy software to do these type of things. So the good thing is that if that motion continues, and this will still take, I think, year plus, but if that motion continues and is successful, at least you can develop one distributed application once, and ideally you can execute it everywhere, in your own data center, in the Azure data center, and maybe even cross-cloud, okay? So that's the thing that I wanted to share with you on Azure Event Grid specific to the edge. Specific to the edge, you have different sources. So as I said, you have the blob, Azure Blob on edge. You can subscribe to that. You can have, again, your cloud events and your custom events, right? So you can have custom modules that subscribe to these things. Now, specific on the final demo that I want to give, I took a real-time analytics scenario for traffic cameras. So you might have that in Finland, but speeding cameras, I think we are familiar with that. What used to happen is they measure the speed at a certain point in time. So the velocity of a car that passes here. So the result of that, people start to know, Waze is alerting that there's a camera in 500 meters. So people are driving at 150 where they can do 120. 100 meters before, they brake. 100 meters after the camera, they take off again, right? And the only result was that people were causing more danger to other people with doing strange incidents. So what they do now more and more is to have segments on the road with traffic cameras at the entrance and at the end. I don't know how Finland is, but this is really coming popular in Belgium, unfortunately sometimes. But what they do, they actually scan your license plate at the beginning, and they scan your license plate at the end of the segment. And these segments can take 8 kilometers, and that's a long time sometimes. So they scan things, but of course, in that segment, as you can see, you have cars that speed faster than the others, so it's not that, it's a sequential thing. This is a typical scenario for streaming processing. So what they do, they scan the plate beginning and end, and then they take the difference of time. When did you pass here? When did you pass there? And that difference cannot be less than the maximum, driving speed. That's as simple as that. This is a common scenario for event detection because there might be thousands of cars coming. Hopefully, there's only a few that speed. Hopefully, depends on if you want to look at it from a safety point of view. Maybe you want to hope that there's a lot of speeding if you look at it from a budget point of view from the government. That's another thing. So what happens is that as soon as the car gets scanned at the left side, an event is being, it's not an event, this is like the time series events, right? This is a stream of events. This is not event grid that I'm using for that one. So I'm using IoT Hub as a telemetry stream to capture all these camera events. So the only thing I know is in which lane was it driving, what type of car was it, the license plate, of course, the make, is it a BMW versus a Jaguar, the color, and so on. And I have that at the other side. So all of that gets into IoT Hub, and that's where I want to detect which cars are speeding, okay? And that's what I do with this architecture. So, and I'm not diving into the details of this one, that's another talk, but on the, so all the data gets sent from IoT Edge into IoT Hub, and on IoT Hub I have two streaming things, just for demo purposes. I have Stream Analytics, that is a SQL type of query that is a standing query and listens on that IoT stream, where it does slicing windows and checks, okay, do I have this happening? So as soon as a speeding car gets detected, it wants to publish an event from that query. The bottom one, the red one, is Databricks. So Azure Databricks is for machine learning, is for structured streaming, which I used in this case, to do data-specific things on cross-platform scenarios. So there I also have a query that is running. It's like a notebook, if you want. And I want to detect suspected cars. So in this case, a suspected car could be someone that is flagged at Interpol, like that car has been stolen and so on. So I want to know that if something happens by one of these cars, I also want to notify. To do that, I'm using Event Grid at the receiving side. So on the left side, I use IoT Hub, which is backed by an Event Hub, if you want, on the messaging scenarios. But on the right side, I just want to throw events from my data structure. So I detect these things, I throw an event, I emit it, and from the data pipeline, I don't want to know, I don't want to care what happens with the event. I just publish it. I don't want to know if they will automatically send a fine or they automatically publish it on a dashboard, whatever. This is a perfect isolation I want to have, and that's a loose coupling. So I publish the event from Databricks to an event grid, and I have the same thing from Stream Analytics. If you think back about the missing publishers that I talked about, I was hoping to do an automatic output from Stream Analytics to Event Grid, because that's a perfect scenario. You listen in an event stream, maybe it could be log files from a website, I see suspicious behavior, I have a machine learning model that detects things, I just want to output that as an event. The reason that I have a function there is just because there's no standard output to event grid. So I had to output to a function, and then the only thing that the function does is using the Arcus library to publish it to the topic. So I hope to see that bypassed. Okay? So if I go to the actual scenario, here's the portal. So I have, and that's also interesting for you to know, if you want to play with this scenario, because it opens for a lot of other types of things if you want to do stream analytics and so on. I also made that open source. So here on my my own GitHub, I have this project where you can just download these things. There's also a container published on, I think, Docker Hub that you can just use. I think let's go here to the README. You can just use and deploy that container on your own, whatever preferred scenario. Here, the public camera simulator. So it just creates a stream of license plates that get created with a little bit of speeding and so on, and you can configure things. So an example is so these events that get configured, and you can start. It's fully explained how to run it, how to store it as an edge module or as a standalone module. The good thing is that it splits these events into IoT Hub. So if you want to play with IoT Hub and you want to have some real life-like scenario with data, that's something you can use for free. So just do the Docker run here of this container for you to use. Now, so that container is running, it's splitting these events in IoT Hub. And then I have this stream analytics. There's too much resources at a certain point in time. And yes, I know naming conventions. So this is stream analytics for people that have not seen it before. So I have a query here that looks very SQL-like. Let's do it in full screen. So this query is just detecting, in this case, I'm joining with segment configuration and so on, which is coming from Blob. But the most important thing is I do a group by, and I group by the traject, so the segment, the camera distance, and so on, and I do that by a sliding window. So I keep 20 minutes of things in memory in stream analytics, and if I see 2 cars, because it's grouped by the license plate, so if I see 2 events from the same car with a date difference, that is, I think here I do that, with a date difference that is smaller than the allowed amount, then I will output, in this case, to speeding events. And as you can see, this is a function. So that's where I was hoping to get event grid as an output. So this function is very straightforward. Traffic demo. So it's an event grid trigger that runs in, or it's a function that runs as with an HTTP trigger here. I called it event grid trigger, and the only thing it does is taking the request body, adding it as an event. Let's zoom in. Yes, so I'm creating a car speeding event, which is just a typed name for my car speeding. I give specific things here, which is the subject ID. So the subject, like the blob container and so on. If you publish your own event, that's how you have to think about how do I structure my things, because the subscribing applications want to register and want to filter on that. And I want to send the car speeding data. So that's my payload. The only thing I do here is I publish these events with the Arcus client to the topic, and that's done. So this is something that I was hoping to emit. At the other side, I have my data bricks running. It should be, it's here. So Databricks, and let's not go in these details, but this is a Python notebook that just runs and listens on all these incoming data streams. It again checks for suspicious cars. And if something of these things happen, what I did, and I hope I still have it here, yes, also open source, is an event grid sync writer. So this is something in Python for people that want to use it. But if you use Databricks with Python, you can publish and you can say, I want to write to a stream to a sync, is what they call it there. And this is just the event grid stream writer that is using these Azure.EventGrid. So this is the SDK from Microsoft that goes for Python. So the good thing is Microsoft is totally cross-platform with these things. So you just run it on Python. And there what I do is just publish these events. So you specify the same things, and the only thing that you have to do is publish these events with the topic URL, and that's how things go. Okay? So that's what I do from this notebook. Again, all of that code is available on that GitHub if you want to play with real-time data streaming and so on. Okay? Going back to the portal, I also have my logic app there that says I want to create a speeding ticket. As you can see, 5 minutes ago there was a car speeding apparently because I have this logic app that kicked off. If I first show how the logic app gets created, so again, Rick will dive into details tomorrow, but you have connectors and triggers. And this is, in this case, the event grid trigger that I can zoom in again, where I specify how do I handle these events coming from my custom application. Well, here I say the resource type is, in this case, not IoT Hub, it's not Blob, it's not storage or machine learning. In this case, it's event grid topic. That means this is for my custom events that get published. Then I specify the resource name, so which topic. And here I say, what type of event do I want to subscribe to? In this case, I want to subscribe to the speeding car detected event. I give it a name because every subscription has a name. And then the only thing that I did in this case was just to show how I can access the event data. The only thing I did was check how to get the license plate from that body. And this is with the perfect, nice language of logic apps that Rick will dive into, because I'm not sure I want to do that today, but I just get the license plate from the data payload here, okay? And if you go back to the results, or to the history, here you can see a replay of one specific instance. You can see that this was license plate 1RX and so on. And here I can do whatever logic I want. I want to create PDFs. I want to send something to another, like the police or whatever, to handle these things. That's all fine. But all of that logic is perfectly decoupled and can be done by a different team than my data science and my data streaming team. And that's something that I really believe is helping the scenarios to be built in a way that we are scalable enough. I hope that the overview was interesting. I hope that you've seen that EventGrid is really in the middle of Azure, of the ecosystem of the services. Only the fact that I think I touched almost all of the sessions that will come later today a little bit with EventGrid is important. So it really allows to build applications at scale. What I think is something that I can give as a takeaway is that you can leverage the out-of-the-box events from Azure. So Microsoft is adding these things, these publishers automatically. So if you're inventive and you just say, I use these events and handle something, it's really powerful. What I also want to do is make sure that you think about, if you build your solution or your application, think about relevant events that you might want to open up for other applications. I think a success today in building cloud-based applications and platforms is really if you can open up for integration and extensibility towards the other world. If you do that with on your own, that's fine. But a nice way to do it is just by opening it up, by publishing all these events to a topic, and then you can have other people subscribing to that. I think it's quite powerful. And the best way to do, and that's something that I've been doing because I started with BizTalk, I said it again, but the best thing you can do is think decoupled in these scenarios. Decoupling is really helping you to scale things and to have a separation or segregation of responsibility. And the last takeaway, please guys, enjoy the conference because I think it's an awesome one. Thank you.
All right. We do have time for some questions that you can shoot out, or you can bug these guys later as well. Next, we'll have a quick break. We'll actually have Martin who runs away next. But before that, we have a quick announcement from one of our sponsors, Microsoft. Yes, Jussi, now a Microsoftie, showing his true colors, a Badger. Go ahead.
Good morning, everybody. Nice to see so many bright faces here. So 2 really quick announcements. My name is Jussi Roine. I work with Microsoft in Western Europe. I'm based in Helsinki, Finland. Reach out to me if you have anything from the community. I'd be happy to hear. I will also try to support the community the best I can. And one of those things will be the Azure Heroes program that kicks off this week. So you can self-nominate, which is always the best thing you can do, or you can nominate somebody else so that they will be recognized by the community as well. And you will receive a badge, and it's based on blockchain, so that makes it even cooler. The second thing is that I have socks. And it's in Seasons colors. I'm not sure who's going to wear this one, but this one has a cloud, so this is really cool. And I will have plenty of these available on this break on the entrance table.
No.
Cool.
Stickers?
And stickers as well. And stickers as well.
Cool. And hey, let's give a round of applause to Jussi because he gave us money so you guys could be here. Microsoft.
All right, so quick break. We'll come back and start the session on time because we are honoring the people on live stream. Already 30 people on the live stream, great. So 15 minutes break, we start again 10:30. And run for the chocks by the check-in desk. Okay. Welcome back from coffee or virtual coffee break, everyone. Next up, we have Martin Baljau, another person in flames. Flaming person.
On fire.
On fire, yes.
This is awkward.
Martin is also one of the returning speakers to Iglooconf and other conferences that we've had. So welcome back, Martin.
Thank you.
Excellent. Let's give him a round of applause.
All right, thank you everyone, and welcome from my side as well. I do want to stress before we start that during the breaks, please talk to the speakers, because we're here to share knowledge and so on. We want to talk to you as well, learn what you are facing and whatever you are doing day to day, and see if we can get something out of that as well. Do be aware, there's two Martins here, and it's pronounced the same. And it's super annoying because every single time someone mentions one of our names, we both look up. So that's Martin, I'm Martin. If you really want to mess with us during the breaks or whatever, just say our name and we'll both look up and be confused. Yeah, you can't tell us apart, that's the thing. So there's that, and yeah, do talk to us, because who knows, maybe we smile back. All right, let's talk about Azure Functions and indexing NuGet on Azure Functions. And what I want to start with is the story on how we started building something on Azure Functions to index things that are on NuGet and so on. So is any one of you using Rider or ReSharper from JetBrains? Okay, cool. Has anyone used the Find This Type on NuGet feature in there? Okay, one person, cool. That's actually a very nice feature because it allows you to write code, and whenever you are using a type that is not yet referenced in a NuGet package, for example, we will show you this quick fix where you can find this type on NuGet.org, and it will install the package into your project or solution, reference it, and make sure your code compiles and you can continue working. So really, really useful to do that. That feature actually was introduced in ReSharper 9 in 2015, I think. The actual idea for that feature originated in Finland. We had a company party at JetBrains somewhere in 2013, which was in Lappeenranta, I think. And we were chatting with a couple of guys on the ReSharper team, like, look, we should have this feature. So we started building that, and finally in 2015 we had it live. And I think Visual Studio also added something similar in 2017. Now, if you start thinking about this feature, you will see that you will need a couple of things. First of all, there's of course the thing that you have in ReSharper and Rider. You want to have that quick fix. You want to have an analyzer looking over your code and checking whether something can be installed or not. But you also need some data store that tells you which NuGet packages are available and which types are available in all of those NuGet packages. And back then, in 2015, we built this out as an Azure Cloud Service. Anyone used Azure Cloud Services? Anyone still using Azure Cloud Services? Yes, they are awesome. They are underrated, but they are awesome. So it's running on that, a web role for the web API that we use in ReSharper, and a worker role on the back end, which does all of the indexing and crawling of whatever is available on NuGet.org. Now, this indexer makes use of the NuGet OData feed, and I'll quickly show you what that beast looks like. The NuGet OData feed is a big bunch of XML that you can address over OData. And what you can do is go to NuGet.org/API v2 packages and then write a select, which is basically give me this view on the data that you have, and then order by last edited, for example, to just get the latest packages that have been added to NuGet.org. Anyone used OData or still using OData? A couple of people. That was GraphQL before it was hip. Right, so we have this thing, and if you load it, you will see that all of the data that is in there, once we render, will be XML-based, and you will have, this takes a long time, you will have a number of entries that are in there. Every entry has an ID, every entry has a category. There's a link to the actual package that you can download. The author information is in there, as well as a number of properties like the package ID, package version, etc., etc. So quite easy for us to parse. and also quite easy for us to page over that entire stream of OData. If you look at the bottom of that OData feed, you will see that there's a link to the next page. So if we click that, we simply get the next page of results, and we can start crawling that as well. So if you just follow all those links, we can index all of the NuGet packages that are available on NuGet. Let's go back to slides. There we go. Now, NuGet over time, and this was a tweet from somewhere end of 2018. Back then, NuGet was 1.9 terabytes in size, whereas in 2015, when we started with this thing, it was only 250 gigabytes. So this is the disk in one of the worker roles that we have there. So NuGet has been growing. That's interesting, because there's only a certain amount of disk space that you can have on Azure Azure Cloud Services in a web and worker role. So we have to be careful that we don't exceed that disk size to be able to keep doing what we do there. Also, NuGet over time has been introducing a couple of new features. Somewhere last year, they introduced repository signing. Well, actually last year, so 2018, they introduced repo signing. And basically what that does is it adds a digital signature to every NuGet package that is available on NuGet.org. Now, what happens is if they change a package on NuGet.org, that also means the entry is updated in the database, which also means that the entry is updated in that OData feed, which also means that we have to re-download every single package that is in NuGet.org at this time. So basically, we had a very long queue in our indexing process because of this operation that they did. We had to re-index everything that was on there. Also, these OData feeds, they are nice if you can get just a couple of pages. Say, I want the packages for the last 2 hours. That's just a couple of pages. But the deeper you go, the more pages you get from that OData feed, the slower that thing becomes. So that's also not nice. Another thing that we saw is that the OData API is actually going to be deprecated pretty soon. So we had to rethink what we were building and rethink what we were doing and think of a better way of getting that data and accessing whatever packages and whatever types are available on NuGet.org. So yeah, a couple of big warning signs for us to start thinking about, maybe we should do something else. And we started doing that. But before we dive into that, I quickly want to talk about the new NuGet server-side API. So you already saw that we had that V2 API, which is OData-based. NuGet can also work with a file system. So if we would download all of the NuGet packages to disk, we could use it from disk and work with that. Or we could make use of the new V3 JSON-based APIs that are available. The V2 APIs, as I mentioned, they start to get pretty slow if you page over a lot of pages, so we didn't really want to dive into those too much and reuse those in a new solution that we were to build. We did want to go for the V3 protocol that NuGet has. The V3 protocol is JSON-based, and it's sort of a resource provider. So if you go to the actual API, index.json there, you will see that that's just a file that contains links to other APIs. It's a resource document describing which resources are available and where they live. You will see in this document that there's a resource for the catalog, which is an append-only event log of everything that happens on NuGet.org in terms of packages. There's package registrations that are used to render details inside of Visual Studio and ReSharper and so on. There's a flat container, which is used during package restore. There's some templates in there to report or to rate packages and so on. There's statistics in there. There's really a lot of resources in that index.json file. For us, that catalog seemed actually quite interesting, because that catalog is what powers NuGet pretty much. If you upload a package to NuGet.org, what will happen is that they will add the data into their database, but they will also add that data into that catalog. They will simply append something into that catalog and say, okay, this package has been added or updated or deleted and so on. And then they run various jobs over that catalog. So when it appears in the catalog, you can run the package registrations, you can build that flat container index that they have, the actual search index, and so on. So they can use the catalog to pretty much feed all of the other APIs that they have. So that sounded interesting. If there's this append-only stream of all of the mutations on NuGet.org, can we, at JetBrains, also use this to see which packages show up on NuGet.org at a certain point in time? A bigger benefit even is that that entire stream is chronological. Everything is appended. There's a timestamp there, so if we want to have only the latest 5 minutes or the latest 1 hour, we can simply find the right resource and read from there. We don't have to read everything that is in there. We don't have to page through all the data if we were to reindex some things. The structure I'll quickly show you in the browser as well, is basically you have the root of that catalog. That catalog lists a number of pages, and every page points to registration or catalog leaves, which contain the actual package details. Very abstract, I know, but I'll quickly show you in the browser what it looks like. So this is the NuGet v3 API, and as I mentioned, what you will see there is a bunch of resources that you can access. So if you want to search, for example, you can see there's a search query service, we can follow that, and we can start using the search API. What's more interesting for us is that catalog that is in there. So if you search for that, you will see that there's a catalog URL that we can use as well. This is the interesting API for us. If we go into the catalog, you will see that that's a very simple index page. Highlight anyway, I'm fine with that. A very simple index page that contains items, and all of those items will be... I shouldn't have done the syntax highlighting. I'm going to refresh this one. The items are going to be links to those catalog pages. So this thing will just be, this page was added at this timestamp. That's what's going to be in those items. I really broke it now. Right. What do you do when something breaks? You restart. And even that is failing. Oh, damn it. Right. This is one of the golden rules in presenting something for an audience. You either try and struggle for 10 seconds, and if after 10 seconds things don't work, you go on and you will tell the audience, yeah, this actually works. So this actually works. All right, so you have the catalog index, you have those pages, and those pages have timestamps plus all of the package details that are available. Trust me, this works. Now, that JSON structure is something that we could read from code as well, so we could page over that entire catalog. But fortunately for us, since NuGet.org is also using this catalog for their own services, they have a library called NuGet.protocol catalog, very appropriate and also very original, that you can use to point to this catalog and see whatever is in there. So what we can do is make use of that library and do a couple of things. So first of all, what we want to do is create an HTTP client that we can work with. Second thing that we want to do is set a cursor. This catalog is a stream of events, a stream of data that is available, so we want to start reading it from a certain point. So if we say null, we read everything that is in there. If we say, for example, datetime_offset.utc now .add hours -2, we will get the packages from the last hour. Anyone here in the audience has uploaded a package in the last hour? No? Okay. It won't show up then. We have that cursor, and we can use that cursor to make use of a batch catalog processor. This is something that comes from that NuGet library that gives us access to the catalog. And what we're going to do is say, okay, I want to process whatever is in that catalog using a client, using that cursor that we have to basically set from where we want to read. And whenever a package is added, I want to execute this code. Whenever a package is deleted, I want to execute this code. So all of this is pretty much boilerplate what that NuGet library gives us. So what we can do is we can run this, and if we run the catalog dump, you will see all of the packages from the last 2 hours live streaming inside of my console there. So if you came here for the learning, I will learn you something. The Xamarin Rise plugin was uploaded at 8:35 this morning. Now you know. Right. Anyway, you get the idea. We have this stream of data. We have this stream of events coming from NuGet.org. And what we can do is react to that based on what their library holds. And we can do something with that, right? So whenever a package is added, we can react to it. Whenever a package is deleted, we can react to it as well. Why is there no package changed operation? Well, since NuGet decided that added is every mutation except the delete. So changed packages will also show up in the added callback that we get there. Right. So since the OData feed is disappearing, since it's not as performant as we would like it to be, we thought, well, should we refactor our existing find this type on NuGet.org in ReSharper to make use of this new v3 API? And we actually did that exercise. We have that running inside of a cloud service in web and worker roles, and that's basically whatever is still powering that search that we have in ReSharper. We were also thinking, since we have to make all of these changes, what would a more modern version of this look like? And that's the remainder of this talk. How could we build this thing using, for example, Azure Functions? We wanted to build a new version, and for that version to work, for that entire feature to work, we would need a couple of things. First of all, we would need something that watches the NuGet.org catalog for changes and deletes and whatever is happening there. For every change in a package that is on there, we want to download the package, unzip it, because a NuGet package is just a zip file, look at the assemblies that are in there, look at the public types that are in all of these assemblies, and then push that into a search index somewhere to keep a link between package ID and version, as well as public type and namespace. So that's what we want to do. Also, since there's a lot of ReSharper users out there, there's some still using various different versions, we didn't want to ship updates to the actual application. So what we also wanted was an API that is fully compatible with what is out right now. So we had to recreate that API as well using this entire new index. All of this is pretty straightforward if you think about it. Watching those changes can be a periodic check, polling that catalog and seeing whenever something happens on there. Every package change sounds kind of like a queue. We could emit all of the events that happen on that catalog into a queue somewhere and then have various processors pick up those changes and do something with that. And the API, of course, could be anything. Could be a HTTP function in Azure, could be a web app, could be a web API, whatever, as long as the thing would be always up and could have a flexible scale going from 0 users to a lot of users that could potentially hit that API. Sounds like functions, because in functions you have inputs, there's some processing happening, and there's outputs. I see a lot of people staring at me with reindeer eyes in headlights going like, what is this thing? This is an actual Microsoft marketing slide. You have input, processing, outputs. Great, every software works like this, I think. The more important things are underneath. That input is something that comes from a convention-based binding. You bind to a queue, you bind to an HTTP endpoint, you bind to a service bus queue or whatever, and that thing provides the input to your code. Your code then does something, but it doesn't have to care about where it should be writing that output. The code just passes along the output to the runtime of functions, and functions handles whatever the output is that is going on in there. Also, this entire flow is triggered by some event, and scale is also based on that event. So if there's no inputs, if there's no packages appearing, nothing will happen, and this thing can even scale down to 0 instances and not run at all, because there's no inputs. If there's a lot of packages coming in, if NuGet decides to re-sign every package that is on NuGet.org, well, we can scale up based on the number of events coming in. So this is actually really a very good fit for functions. And we started building functions. We have the catalog. We have one function looking at whatever is happening in that catalog. We enqueue the fact that we want to index that package. We also added a second queue to download the actual binary, so we have a copy of it for further analysis at some point if we want to. Both of those queues have their own functions listening to it. One to download the package, one to actually index the package and push it into Azure Search. And then once we have that, we can have an HTTP triggered function to basically provide the API into whatever data we have in Search. So let's start building that thing. Collecting from catalog should be relatively straightforward. We actually already built it in this program that I just showed you. What we can do is create a function that pretty much does the same thing. So what we can do is, in our type search thingy here, create a new timer trigger. Add that thing, call it Iglooconf. There we go. We can add it, we can run it every 5 minutes, maybe every 15 minutes or whatever. We get a timer from the Azure Functions runtime, and then we can write our code, and I will do that in the quickest way possible. There we go, our code is there. Again, this code is roughly the same as what we had before, so it will give us the catalog client. We will follow a cursor, and for every package on there, I will log to the console, not yet push into a queue or whatever, just pretty much do the same thing that I had in that console application, but now as a function. I feel so modern. One difference here, though, is that instead of passing in a hard-coded date timestamp to that cursor, I get something for free from the Azure Functions runtime. I get this timer object, and in that timer object, there's a schedule status.lasts. So if I want to run this thing every 15 minutes, Azure Functions will actually give me the timestamp from 15 minutes ago, and I can incrementally index whatever is on there. If I have the last result, I can stop running, and 15 minutes from now, this thing will start again and continue where I left off the previous time this function ran. So pretty straightforward, just using that timer trigger and running it every 15 minutes. So let's run this one. And by the way, a very interesting thing coming up in terms of how you can debug your functions. So this function is now running. It will run every 15 minutes. So you can choose. Either we wait 15 minutes for it to kick off, or we trigger it. And I don't know if you knew this, but you can actually trigger every Azure function using either the get endpoint, if you have a HTTP-based function. But if you have something like a timer-triggered function or something like that, what you can do is post to your local functions runtime, /admin/functions, name of your function, pass it no data, and it will kick off the function, and the function will run. So just as a quick thing to learn here. So my function will run, and if we look at that, we will see an exception. Awesome. I know what I did wrong. So anyone know what I did wrong here in my logic? I get back the last time this thing ran, but if that last time is empty, if it didn't run before, it will always be empty, which means I will fall back to .utc now, but .utc now is now, which means unless someone uploads a package now, nothing's going to happen. So I have to also add that -2 hours there. So let's copy that over and add that there as well, just to be sure that we can show something. I know this is not the most exciting demo if you just look at the console outputs, but I want to prove that this works since I already had one demo fail on me before. Right, function is running. I'll trigger it again from my HTTP client there, go back there, and now you will see still that error message. Come on, this worked before. Might actually take a while to get the data from the, well, assume this works. Like I said, the 10-second rule, right? Oh man, this is going great. Why do you keep inviting me?
It's fun, man. Look at yourself.
All right. Yeah. So talk to Martin. Right, let's go back to slides. At least I can do that, right? Good. So if you look at the function that I just wrote and that we all saw worked flawlessly, you saw that I was creating all of this infrastructure to basically get something from that catalog and then write something to console or push something into a queue. That's not super ideal. Ideally, our functions should be doing just one thing, or at least as few things as possible. And actually, Paul D. Johnston, anyone know that name? He's someone who worked at AWS doing all of the Lambda stuff there, so he's quite familiar with the entire functions and event-driven patterns. And he has a blog post detailing the function's best practices. And one of those best practices is that every function should be doing one thing, and only one thing, or ideally as few things as possible, because it makes it, first of all, easier to handle errors. If something breaks, you don't have to go through 50,000 lines of code. It's going to be just a couple of lines of code. Also, for scaling, if you want to scale just one small component of the application, you can do it independently without having to scale all of the functions that you have in there. Also, this does mean if you want to decouple things, if you want to work with smaller units of work in there, you will have to learn how to work with messages and queues and get this asynchronous messaging or communication happening between those functions. Now, that all sounds nice in theory. In practice, the Azure Functions team actually follows those guidelines. If you build your functions on Azure, you will know, you may have probably already seen, that there's a number of bindings that you can use in the application. In my example, that worked flawlessly again. We had a timer, and a timer will trigger the execution of a function. You can also have blob triggers and queue triggers, table triggers, and so on. They will trigger a function. Whenever something happens in one of those mechanisms, the function will start running. Additionally, you can have bindings that provide inputs. Remember the marketing slide that I showed earlier? You can have a function that gets its input from a binding. You can have a function that gets a blob reference or a message from a queue or a table record or whatever, and get that passed into your function. Same thing with output. Yes, you can write manually into a storage queue or into a message bus or a service bus queue, but ideally you just say, okay, functions runtime, I have these 5 messages for you. Can you please go ahead and add them into a service bus? There's one special trigger on here as well, and that's the HTTP trigger. What I like to think is a lot of people think that functions are really just for hosting APIs or just for hosting something that uses one of those bindings. I think they are the same. We are talking about message-driven or event-driven architectures on functions, and an HTTP request message coming in is just a message again. It only happens to come from a browser or another HTTP endpoint, but again, it's just a message that is triggering the function logic, doing something, and reporting something in a different outputs. Now, all of those bindings are there out of the box, but you can also build your own. I've seen on the internet Dropbox bindings where you can drop files on Dropbox. I've seen Christian Weyer, who has spoken here as well. He built a SQL Server binding where you can basically write a query, and whenever data shows up there, it will trigger your function and give you the data from your SQL database. The only binding that I feel is missing is a NuGet catalog binding. I would need that. So I decided, okay, let's maybe talk to Microsoft and ask if they can provide something like that. Wasn't going to happen. So had to think about writing my own. Now, this catalog binding should be something that triggers logic. Whenever we see something on that NuGet catalog, we want to trigger our function execution and do something with it. All of these custom bindings that you write are supported. If you create custom input or output bindings, they are supported by Microsoft. The documentation says, yes, you can do this, this will work. Custom trigger bindings, the documentation says this will not work. So that's an issue. Fortunately, we learned that it actually does work. There's only one thing that you should have, and that is that the instance of your, so the server that runs your serverless functions, has to be an always-on server. So it cannot be a consumption-based plan that you have. It has to be always running so that the trigger can run in the background and whenever something happens can invoke the functions that you have running. As long as you do that, in the more than half a year that we have had this thing running, we've only had our custom binding crash once or twice. So it's actually stable if you make sure that it's always running. With that, let's create a trigger binding. And you're in for a lot of code, and I hope this demo will work. Right, so we had all of those approaches, and ideally, instead of doing all of that, instead of doing all of this, where we have our catalog and we watch that catalog, and when the package is added, we want to add it into a queue and then do something with it. All of this code is way too much, actually. Ideally, we want to do something like this, where we have a function that gets triggered by a catalog trigger, and whenever we get information from there, we forward it into a queue and log the operation to the console. Now, to make sure that this thing actually works and that this demo will work, I will try and run this just to prove that this will actually work. There we go. So it's running. And we can see that packages are actually being added into our queues. So if I would look at my storage account that I have configured, I will see messages for every single package that was added into the catalog. So my binding works. That's great. First working demo. The thing I'm interested in now is looking at how we wrote that NuGet catalog trigger. What we do here is say, okay, I want to have a package operation be provided to the function that I have running. That package operation should be provided by this NuGet catalog trigger that uses a cursor blob name with the name of enqueuer. Remember that when we were reading that append-only catalog from NuGet, we had that cursor where we want to have a timestamp that keeps track of where we are in that stream of data that is in there. Well, this cursor blob name is where I want to store the data that we actually need to be able to know where we are in that catalog. So if I would look at our storage account there, look at the NuGet catalog trigger there's a cursor, and if we open that one up, what's that again? Trust me, there's a timestamp in there. We'll do it that way. So that just holds a timestamp to be able to know where I am in that stream of data in that catalog, to be able to work with it later on. My catalog trigger itself is fairly simple because it's only a data attribute that provides some configuration options to the Azure Functions runtime. So our catalog trigger attribute is an attribute that has a service index URL, which catalog do we want to talk to. One where I can say previous hours equals 2, so that I can run on the previous 2 hours, for example. That has a connection to storage, and that has that cursor container and blob name where I will store that timestamp. This is all that there is in this attribute, just configuration values that I can either provide whenever I add that attribute into a function, or that I can hard code and have as a default. More interesting is that our catalog trigger attribute has an attribute itself called binding. This actually tells the Azure Functions runtime that the attribute denotes a binding, that we want to bind to some data based on whatever we have there, and that the runtime should be doing something to hook everything up and make it work. We have that binding there, and that's basically telling that. Now, if you would look at the documentation of Azure Functions, they would say if you have this and your actual trigger has the same naming conventions, all of this should work. That's a lie. The documentation should also state that you have to add a web job startup that also adds your binding as an extension. So I have to add a binding provider and an extension configuration provider there in that startup file, just like you would do in an ASP.NET Core application, for example, but you have to register it. Right. Now, I think we can all agree that this binding is not going to do a lot of things, and there should be more to this, right? I mean, it can't be that all of this is what makes the function work. So what we need is we have to write our own configuration provider. So if we have our catalog binding, what we have to do is create a configuration provider. And that configuration provider is going to follow naming conventions, so it has to be NuGet catalog trigger and then whatever config provider, but that thing has to be in the name. And what we do is when it initializes, when the functions runtime starts, we add a binding rule stating that whenever functions runtime, whenever you encounter this attribute that I created, bind it as a trigger binding to my trigger binding provider. That's what we do. This is basically on startup telling what the runtime should be doing with the attributes that it encounters. Now, of course, we need that trigger binding provider somewhere as well, and that's another one that we have. And also, this is, for some reasons, also naming based, so it has to be the exact same name as your attribute. So, pro tip here, don't make long attribute names, because every class will have a very long name. But this thing is actually where the logic starts. So we registered everything. If the function's runtime invokes my NuGet catalog trigger attribute binding provider, that's where the magic will start happening. What we do in here is when the function runtime creates this thing, we will look at the parameters we get. We check if the parameters are actually the attribute that we defined. Then we will do something with it. What we're going to do with it is set up a connection to a storage account, set up a connection to a blob client and to a cursor container so that I can already prepare that cursor blob that I will store with a timestamp on running over the entire catalog that we have. That's all we do here, initialize all of those things, and then we return a NuGet catalog trigger binding. This is the actual binding, finally. What our binding is going to do is take in whatever we constructed with, so that's that blob URL to where we want to store the cursor, and it's also going to create a listener for data. This thing is going to create a listener because it wants to trigger a function, so it also has to listen to some data to be able to invoke the functions that we have on the other side, right? So what it's going to do is create a NuGet catalog listener, and I'm going to dive into that one after this small break. It's going to do that. It's going to listen and invoke that thing, but it's also going to provide the data contract with the function's runtime. Is any one of you writing Node.js functions or different languages to C#? Yes. If you want to write a custom binding, you can do so. If you have a Node.js-based function, you can write your own custom bindings, except those bindings have to be written in C#. which means that you don't have the strong typed way of working with data that you have there. So what you will have to do in your custom binding is provide this binding data contract and tell the runtime what the shape of the data is. I'm going to say, look, I have data, which is going to be the raw JObject that I get from the catalog, but I also have a property called ID, version, published, package URL, listed, action, etc., so that if I have a Node.js function, I get a nice JSON formatted object with all of these properties. I know what type they are, and I can work with the data that I get from the functions runtime and from my custom binding. If you're doing just C#, you can forget about this and just pass along the data. But if you want to play nice, make it possible to use other languages as well, make sure you keep those around as well. Right, with that out of the way, let's go into our actual listener. Our listener itself takes whatever we initialized up till now, and what it's going to do is set up our entire catalog processor. Everything we had in our console application previously, instead of using an in-memory cursor, I'm now going to use a cloud blob cursor, which points to the blob that I am storing with the timestamp of where I am in the catalog. I'm going to create a catalog leave processor that will trigger a package added and package deleted function, and that's pretty much it. So my listener is going to do that, spin up this thing, and whenever it encounters data, it will call into one of these two methods. Those two methods are where the magic happens. Whenever a package is added, whenever we see something happening on the catalog, we will try and execute our trigger with data that contains the package ID, package version, published date, is listed, etc., and I'm going to try execute that on my executor. This line of code is the trigger. Whenever we invoke this in our binding, the function's runtime will trigger the function with the data that we provided. So whenever you see a package scrolling down in the log that I had previously, that is whenever this try execute async is run. Cool thing is, the Azure Functions runtime will make sure that this scales if you have multiple instances, that it's distributed and fanned out across instances and so on, but this is where the actual triggering happens. So yeah, that's it. Any questions on custom binding or custom trigger bindings there? Is it hard to debug these things? No, it's actually not. So we have our function that we have. So if we go back to our enqueuing function here, what I can do is place a breakpoint in there and see whenever data comes in. If I have something in my actual trigger, what I can do is go into that listener that we had, put a breakpoint, run through it, and I can see whatever is happening. So everything you expect to be able to do during a debug session will be available, and you'll be able to see what is going on internally, at least in the code that you are writing, to see what is happening in there. Hope that helps. Cool. All right. So yeah, that's our binding. Pretty nice. And instead of that big bulk of code, what we can now do is simply have that catalog trigger and then forward it into a queue. Does anyone find this strange? That I have something that triggers a function, that I'm enqueuing something, and then I'm having that queue trigger another function to actually do the work. Nobody finds that weird? It's not weird. The reason for that is our catalog is single instance, or at least the cursor that we have is single instance. We want to follow that entire stream, so ideally we can only have one reader on that catalog without having a lot of synchronization logic. So what we do is we have this NuGet catalog trigger that will run as a singleton, so there will always be just one instance of this function reading from the catalog, populating a queue, and from that queue I will start fanning out across multiple other functions that we have in the solution. Make sense? Cool. Right, we're making progress. We are watching the catalog, we have our queue being read and so on, and we can start working on the actual indexing and downloading of the packages that we have. So let's do that. And let's start with downloading the packages. Downloading the packages is going to listen to this queue collector that writes something into that indexing or downloading queue. And what the download is going to do is fairly straightforward. What it's going to do is, of course, be a function. My function will be triggered based on that queue that I was adding messages to. And whenever there's a message in there, I will check, is it an add operation or a delete operation? And based on that, I will either download the package from the internet and upload it into blob storage, or delete the blob. So not a very complex function, just doing 2 operations, but it makes sense to group them into one function for this purpose. Now, what I did want to mention here is that instead of setting up a connection to blob storage myself, what I'm doing here is making use of the output binding called blob. And my output binding is going to be a read-write blob using my downloads connection that I have, and it's going to provide me a reference to a blob that I can write to. So I don't have to care about read-write policies. I don't have to care about getting the connection to my storage account and so on. My function will get a blob, and I can simply write data into that blob. I don't even have to care about the name of that blob that I'm writing to. As you can see here, my blob path is going to contain the ID, the normalized version, and then ID and version normalized again, .nupkeg. This is going to be the file name of my function, where ID and version normalized are going to be replaced with what I get from my package operation. So I don't even have to care about that. The function's runtime is making sure that I can just write to that blob and push everything in there. So downloading, fairly straightforward, I think. We're done with that. Now let's talk about indexing packages. Indexing is going to be slightly more complex. Let's park the functions runtime for a while and look at how we can read from the packages that we get from NuGet. So I already mentioned that NuGet packages are zip files. And if you open them up, you will see a list of assemblies in there that you can read from and do whatever you want with. Now, if you were to build a solution like this, would you use reflection to load those assemblies? Imagine you are indexing 2 billion packages. You would not want to use reflection there. Reason is, everything is polluting your memory space. There's chances of all things going wrong, so you don't want to load those assemblies, but you still want to have the metadata that is in there. Turns out, since .NET Core, there's a nice package called system.reflection.metadata that you can use to open up a stream to an assembly and look at whatever is in there. It doesn't load the assembly into the process. Instead, it just enumerates over whatever metadata that is in there. Actually, an assembly in .NET, I don't know if anyone is familiar with this. An assembly has a header, the portable executable header, and in that header is all of the metadata that we could possibly need about the assembly that we are opening. So we can use that. Next thing we want to do is, once we have all the data from the assembly, is push all of that into a store that keeps the relation between package ID and version, plus the namespace and the type of the assembly. Could be Azure Search, could be a database, could be something else. We chose Azure Search, and we're diving into that in a little bit. Let's first talk about that system.reflection metadata. If you open up your decompiler and open up any decompiled assembly in there, you will see that there's a metadata node in that decompiler, and that metadata node is that PE header that I just talked about. That is where you can see the metadata of everything that is inside of your assembly. You will see there's going to be strings in there, some blobs, some random data that .NET needs to be able to run your application, and there's also going to be a table called typedef. And that is the table containing all of the type definitions that we have in the assembly. And if you look into that one, you will see that this type definition with the pointer 2 has a name of bearer token connection. So that's a public type that is in there. Now that name was retrieved by following links, because that name is actually a pointer that is also in that metadata, and that pointer goes into the strings that we have in our assembly. So if we use system.reflection.metadata, we can start by reading from the type definitions, getting the pointer to the name, following that pointer, and then getting back the name from the assembly that we have there. I know, quite complex. I'll make it worse using some code. I have a PE reader there, which is coming from that system.reflection metadata class. And what we do is enumerate the type definitions in the assembly that we just opened. For every type definition, we read the type definition namespace and name as a pointer. And then we use that getString method to actually get the data for that pointer, and then we can use that to index our class. You also see that if statement there. For the functionality that we're building with findThisType on NuGet.org, we don't care about display classes or compiler generated or statics or whatever that are generated. We just want the things that you as a developer will be using, so we filter those out in that loop, and we're not interested in following those. Make sense? Cool. Next thing we have is, once we have cracked all of those assemblies open and we have all of that metadata, what we want to do is push all that data into search. Anyone used Azure Search or is using Azure Search? Anyone using Elasticsearch, Lucene? They're all roughly similar in the way that in that search as a service, which is Azure Search, you define an index. That index will hold documents, which is like in a database you have records, or in a table you have records, so you have an index with documents. And every document will have fields. Those fields can be searchable, they can be facetable, which means that you can sort of group them together. They can be filterable, which means that you can filter on the data that is in there. Makes sense with the name, right? They can be sortable, and they can be retrievable. All of these properties of a field in a search index have to be specified up front. You cannot change them when your index is already live. So if you are storing the package ID, but you didn't make it retrievable, there's no way for you to get the package ID out of that index again. So you have to think about what that data structure will look like up front, because if you want to change it, you have to reindex everything. So that's one of the downsides there. So think about what you want to search and what data you need in the API that we're going to build later on. And using that, we can start building the index that we have. So let's index our packages. 15 minutes left, which is a good thing. I can not show the demo, but just show the code, which is safer. Right, our indexer. We have our package indexer, and what our indexer is going to do is it's going to listen to our queue again with indexing operations that are coming in. We get package operations, which are in the shape of an ID, a version, published date, and all of that information. And using that, we want to start indexing. So what we can do in our function is create a client to the index that we want to work with, and then we can create a list of index actions, and at the end of our logic, submit all of those index actions into Azure Search and make sure the documents are available. I know this looks like not a lot of code, but it gets worse. If you go into the run add package async, this is where we index a newly added package. What we do is read our package from NuGet, store it on disk. I know, serverless, but we store it on the disk of our server. The reason for that is NuGet also has packages that are 500 megabytes in size, and I do not want 500 megabytes in memory. I do not. So that's why I'm storing them on disk in my serverless instance there. Storing it on disk, once we have that, we open up the package, the zip file that we have there. We get some metadata from the package, so package ID, package version, description, summary, all of that is in the metadata that NuGet provides. And we start creating a package document with that. Then we have the code that I just had on slides. We go through all of the assemblies that are in there and so on. And once we have all of the type names, we push them into our package that we want to index. And once we have that, we index it into Azure Functions. I know I skipped over a bit of code, but it's basically just making stuff work, so not that interesting. But suffice to say that we have the metadata, we push it into the index, and we also have the data we get from the assemblies, and we also push that into the index. Now the index, what does it look like? We have our package to index, and package to index is a package document. This is where we specify what the shape of our index is going to be. This is where we specify the fields that we have in the index. So our package document is going to have all of the properties that I just showed you in the slides. First of all, I want to have a primary key on my identifier that I have there. Package ID plus version is going to be my identifier. Why would you want a key in a search index? The reason for that is that we also have download counts to take into account at some points. And what we want to do is be able to update just that property. So if we have a primary key, we can sort of get the existing document, change that property, and store it again in the index. So that's why we want to have a primary key. Not required, but it can be useful for certain scenarios where you want to update data. My package ID is going to be searchable, of course, because I want to be able to search for a specific package. It's going to be sortable so that I can do some sorting operations on it as well. And it's also going to be retrievable. Since in ReSharper and since in Writer, I want to show the package that is going to be installed in your project, ideally, I want to show that package ID, so I have to make it retrievable. If I only want to search this field but never need the data to be shown in the UI, I could not make it retrievable. But again, think up front what you do with that document. So there's all of that. Some fields will be not retrievable, some fields will be retrievable, and some fields will have a specific analyzer. Anyone familiar with analyzers? Not a lot of people, so I'll quickly explain. Analyzers are basically a step right before your data goes into the index. An analyzer will run, and it will strip some unnecessary data from the fields that you are storing. If you want to store texts into a search index, to search texts, has anyone ever been searching for a dot or a question mark or an exclamation mark? I don't think so. So most indexes are going to have an analyzer that automatically filters those things out, because for searching, you don't need that data. Now, since my type names will contain namespace dot something else dot type, that dot is actually significant, so I need that dot. So what I'm going to do is override the default analyzer, pass in the simple analyzer name, and this is going to basically tell Lucene or Azure Search that I just want to store the raw data that I pass it, instead of stripping out the dots. This was interesting. After a couple of million packages, I realized that I forgot to do this, so I had to reindex again and again to make sure that I actually had the dots to search on. Anyway, back to our function. In our function, you see there's a lot of code, which also does the boilerplate thing, like getting a client to my search service, making sure that I have the index actions, then creating an index batch, pushing everything into Azure Search, making sure that if there's an exception, I handle the exception, and all of that information, or all of that boilerplate codes. And I feel that I don't really want that in my function. And if we think back to that rule of doing one thing and only one thing well, we should actually be moving all of that boilerplate code into another custom binding, so that we can just say, okay, Azure Functions Runtime, I have this document I want you to index, use this binding, here you go. And have a custom binding handle all of the search stuff that we have in there. So let's look at that. 10 more minutes, we're totally fine on time. I have a version that uses a custom binding. And instead of having all of that boilerplate code that we had previously, what this function is going to do is it's going to still be triggered by the queue that we have. But instead of doing all of the Azure Search things manually, I'm going to have an output binding called Azure Search Index that uses a specific search service with a specific API key, a specific index name, a certain shape of index documents, and I want to merge or upload things into that index. And then have a document add collector. In my code, still a lot of code to do all of the extraction of the namespaces that we have, but in a sense, what this run add package async is going to do near the end is going to say, where is it? Document add collector, add this package that I want to index. Instead of doing all of those things manually, I'm just passing it on to the functions runtime and trusting it to trigger my, or use my output binding to store this thing into Azure Search. So let's go to our custom binding. Again, the binding attribute itself is not that interesting. It's just the data that I need for it to function, and I have to again annotate it with the binding attribute there. Also, don't forget, we have that startup class there. We also have to register our function as an extension. Don't forget this. And this thing is where the magic will start happening. We had this with our custom trigger binding as well. Now we need it for our Azure Search extension provider. But instead of adding a binding rule that triggers a function, this time I'm going to say, okay, for whenever you encounter the Azure Search index attribute, I want you to bind it into a collector. Collect data, push it into something. I'm going to bind it to a collector of type that provides the type OpenType, and that uses this Azure Search Async Collector Builder. Quick note on this OpenType. I could build a custom output binding that just collects package documents for my use case, But I thought, okay, if I need to store stuff in an index, maybe I need to store stuff in a differently shaped index at a later point in time. Maybe someone wants to reuse this binding and use whatever shape of data they have. I want to be able to work with any type of index document, and that's where the open type comes in. It basically tells the runtime, give me whatever you want, and I'll figure it out and see what the shape of the object is. Since I'm using OpenType, I have to implement this Azure Search Async Collector Builder, which is going to make the concrete type for my package documents that I have. So this is going to, under the hood, create a proper collector for the type that I want to work with. This collector is going to be much simpler. So trigger bindings, we needed the trigger binding, we needed the listener, we needed the configuration, and then execute something. This one is basically you have the attribute, the configuration, and then there's the binding. So we have our binding. And whenever the function's runtime wants to add data into the output binding that we have, it will call into add async. And in here, what we're going to do is index the item, make sure that if the index does not yet exist, I'm going to create it and then try re-indexing it just to handle all of those edge cases in that binding so that I, again, can have very clean code on the other side. Make sense? All right, cool. One more thing. We're almost there. We have the indexer, we have the catalog watcher, we have the downloading, and so on. All we now need is the actual find type API that ReSharper can use. So let's build that, and we can do that using an HTTP trigger binding. Again, I'm creating some sort of an API on Azure Functions, but think of this as an HTTP request message coming in, input, you doing something with it, and then providing output, which is going to be a JSON response that the API will return to the clients. So let's make this work with ReSharper and Writer. Not a lot of interesting things are going to be going on in there, so I'll quickly show you what our web API looks like. We have this find type API, and what it's going to do is listen as an HTTP trigger on a certain path. It's going to listen on a second path as well, because we also support searching by namespace. I'm going to close this one. And once we have that, we can run that search internally. So what are we going to do here? Fetch the parameters, which is basically what the API has to provide, and at some point, search in our index. One thing that I do want to mention here, because the indexing itself and the resulting and the formatting for ReSharper is not that interesting for every use case, but what is interesting here is the type of search that I'm doing. Remember that in our package document, we had this type names hash set with a simple analyzer. This is where all of the public types are in. So if I search for newtonsoft.json.jobject, that's going to be in this type names object inside of my index. Now, things like Lucene, for example, only supports one level of properties, whereas Azure Search allows you to have a document that also has a collection which can contain other types of data. So that's a difference there. And what I'm going to do is make use of the feature that allows you to search inside of those client properties or those sub-properties of your document. So what my search is going to look like is if I search for a type, I'm going to search in my type names columns for .typename, because that's going to be the last part of my string, newtonsoft.json.jobject. So I'm going to search for that. If I search for type name, I'm going to do the inverse. I'm going to search for the namespace dots. So if I search for newtonsoft.json.jobject, I don't care about the .jobject, but I'm still going to search for newtonsoft.json dot, just to get that data. Pass that into my search service, to Azure Search, collect the results, and so on. Anyway, believe me, this works, and I will actually show you this works. And this one will work, I promise. I can use it in the browser. So I have the API here. If I search for JObject or let's say JSON convert, popular thingy, I will get a result back, and my index will give me, there's a package called newtonsoft.json, where you can find the icon there. There's this amount of downloads, the description is in there, and your search matched the following assemblies and is available for the following platforms. And by the way, the explicit type was JSON convert in that namespace. So that's my API. If I now start ReSharper and I run it in the internal mode and I'm using a JObject that is not yet available in my project, what I can do is Alt-Enter, find this type on NuGet.org, ReSharper will start searching using my new API, will show me Newtonsoft.json, and I can start installing it from there and have the entire flow working. Right, trust me, that worked. One issue left, and that's one that we still haven't figured out how to do this properly, download counts. In a search index, you typically also want to include some relevance. If Zachary posts a NuGet package to NuGet that contains an object called, or a type called JObject, I want to be able to have Newtonsoft.json first and Saka second, or maybe even further down the list, because I'm probably after Newtonsoft.json, right? So I want to use download counts to provide that ranking and make sure that things are somewhere on top. Now, the downside is that currently the NuGet v3 API does not provide download counts. So I've opened an issue. I hope at some point they will see the third or fourth recording of this talk about me bitching about download counts, and they will start implementing that. Now, if the data existed, if there would be an API with download counts, I would update my index every day, every week, or whatever with those new download counts by using that key that I had in my package documents. I have my package ID and version. I can use that as a primary key and merge the download count in there using a merge operation in Azure Search. So I don't have to reindex every single object or reindex every single package. I can just update one existing package document. Right, we're done. The entire flow works. You've seen it works. I've actually searched in ReSharper and showed you it works. I do want to give you a couple of closing thoughts here. So everything works. We found that when we ran the last full index we did back in May 2019, we did it in 12 hours on 2 B1 instances on Azure. Anyone familiar with VM sizes will think that's a very low-level machine, and it actually is. It's a very slow and low resource machine, and it works perfectly. Only 12 hours to index all of NuGet. We can probably speed that up on bigger machines. We can probably make it faster if we scale out to more instances, but 2B1s are, first of all, very cheap, and they do it perfectly fine, 12 hours to do a full index, whereas our current solution takes 2 weeks to do a full index. So 12 hours is awesome. We found that the NuGet.org homepage back in May last year was lying. They said 1.7 million NuGet packages available. There's actually 2.1 million available. We also found that there's 8,400 pages in the catalog with approximately 4.2 million catalog leaves, which makes sense if you think about it. 2.1 million packages in the index. They did the package signing at some point, which means every package is added again, so exactly double the amount of catalog leaves that are in there. I checked the index last week, I think. I found right now there's 2.6 million packages and roughly 3.5 terabytes of data in NuGet.org. If you want a copy, I can download it for you. Right, some closing thoughts on the functions approach here. You saw that we basically have a couple of roles. We have the package, the catalog watcher that watches the catalog. We have the actual indexing, and then we have the search. I would deploy all of those in separate function apps for a couple of reasons. First of all, for costs. Our watcher has to be running 24/7 on a reserved instance because it's a custom trigger binding, and it has to be online basically all of the time. It can be a small B1 instance, but it has to be running all of the time. The indexing can be consumption-based. Whenever there's no packages to index, I don't even want the indexer to run. Whenever there's packages coming in, they can spin up and they can scale independently. That's the third point, actually, scaling independently. If there's no packages, that can scale down to 0, whereas my API can scale independently from the indexer as well. Many requests, many HTTP endpoints, almost no requests, maybe very few capacity that is required there, or I can even use consumption and scale it down to virtually nothing. All of those things are also making it easier to monitor whatever the functions are doing, and yeah, you can basically keep things separate for cost and for fault domains. One note about bindings. If you care about vendor lock-in or framework lock-in, I would say, maybe it's not the best idea to use them if you want to move to OpenFaaS or whatever, use something more generic and do more things yourself. If you're all in with Azure Functions or web jobs, or you run web jobs in your own container, and it doesn't really matter that you're tying yourself into Azure, perfectly fine. Bindings are really nice to work with. Once you have them, your code becomes super clean, very reusable, and yeah, I would say go with them because the custom bindings really make it nice to work with. With that, thank you for being here, and yeah, talk to us if you have any questions. Find us and go ahead. Thanks.
Thank you, Martin.
I went over. Cool.
It's okay. It's only away from all of our lunches. So to find the lunch, please go ahead and find the decapitated polar bear on the back, and just follow the polar bear over there. That yeah, I promise there will be actual food at the end. And for our live stream audience, we will be back in not 60 minutes, but
56.
56 minutes. All right, food.
Yep.
is. Wait, still have something. Apparently, I'm the Justin Bieber of Azure. When did that happen?
Two, 1, 2, 1, 2, 1, 2, 1, 2. I don't know number 3. Cool. Let's wait a while. Are there a lot of people there outside still? Okay, cool. Give me a signal if there's a lot of people outside. Do a dance. I don't. I'm an idiot. I will have it soon. All right, looking like we have some people back. Tummies are full. Everybody is tired. We have a guy on stage calling us idiots. Or how did it go? Good start.
Actually, Mike's is full, but I will explain it over some drinks maybe later. So.
Oh, he will get some drinks later. That will help. So, let us welcome Glenn on stage by clapping. Thank you.
Thank you. Receiving applause before a session is always nice to start. I hope everybody had a great lunch. People are still coming in, so let's hope they get everything out of this session. So before we start, you're probably wondering, so why is this Belgian guy wearing a Azure shirt? So, oh, clicker not working. That's a great start. So I'm happy to announce that as from today, Azure is expanding to Belgium. I'm happy to work with these crazy guys to make the internationalization of Azure a success. Really looking forward to work with these guys to build awesome Azure stuff. So for people who don't know me, I'm Glenn. So as already said, I'm the founder of Azure Belgium. I'm an Azure MVP. I'm also part of the Azure user group in Belgium. Feel free to reach out. I now have a very cool Azure address, so you can drop me any questions you want. I will be happy to help you out. So Azure has been doing Azure since 2011, 100%. I'm very lucky to be surrounded by an awesome group of experts. Everyone in the crew is an expert in their business, so it's really awesome to join them. Once again, I'm very honored to do that. So we also have lots of logos from Microsoft, which is always cool. So let's talk a bit on IoT. So in the title there was rabbits, so I had to do something with rabbits. So the most important decision important decision a company has to make when building an IoT platform is choosing between implementing a software as a service solution or building your own solution with PaaS services, basically allowing you to have full control over the solution that you're building. When you're doing SaaS, you give away a bit of that control in favor of getting started more quickly. So it's a decision that most companies have to take very early in the process, and it's also one of the most important, or the decision with the most of the impact. Next to that, having an idea on what business value you're trying to get from your IoT solution or from your cloud platform in general is also a major part of that initial decision making.
So I've been involved in quite some IoT project that start off with the R&D department. You build up a proof of concept from a couple of days, and then they have to start building that business case and need to defend that business case to the upper management. So that's basically bottom-up driven, but IoT really needs to be implemented strategically inside the company. So everyone in the company needs to be behind that decision of starting an IoT project, and it has to really be lived throughout the entire company to make that IoT solution a success. So let's quickly run over the offerings of Microsoft regarding IoT. So the title chosen here is a trip down the rabbit hole, which basically means there's a lot of offerings. You can use them for different purposes, and it's sometimes not easy to choose between them. So during this session, I will guide you through these services, see what service you can use in what case, and what you can leverage from what service in what scenarios. So first of all, there's the Azure IoT solutions. So these sail under the software as a service flag. So there's IoT Central. So has anybody ever worked with IoT Central? Knows what IoT Central is? Okay, great. I have a demo later on. So then you, of course, have the IoT accelerators, which are basically just your, let us say, reference implementations of Microsoft. These are fully open source, built on microservices. And what you can do there is pretty neat. So you can cherry pick pieces of that and implement them in your own solutions. Of course, then you also have connected field services. The most important area, or that we see, is the PaaS services regarding IoT. Of course, you have IoT Hub, which is your main entry point for all your IoT solutions in Azure. Then you have other services that leverage that data coming in, streaming analytics, Cosmos DB, time series insights, and device provisioning service. But I will come back to most of these services later during this talk. And then, of course, there's a whole edge support, which is really booming these days. There's IoT Edge, and most of the Azure services are starting to come to the edge. Martin, not the other Martin, will talk about IoT Edge tomorrow after lunch-ish. So all of these services are backed up or are supported by Azure Security Center for IoT. I believe this is still partially in preview. So what this does is this will analyze how you're using the IoT services of Azure, and then potentially discover any breaches onto your devices or anything else. I will show them later on. So there's also a whole other area that's not on the SaaS or PaaS level, but it's really all about the devices. It's Azure Sphere, Windows IoT, and edge devices that Microsoft is supporting. I will not go into details of that, because that will lead us too far. But what I do wanted to mention is Microsoft has put out a white paper, which they identified the 7 properties of a highly secure device. 7 properties of how a device should be configured or programmed to be highly secured according to the standards. So how does it do error reporting? How is your device security, and so on. So there's a very interesting white paper. You can find this here. I believe slides will be shared afterwards, so you can download it then. If you want, you can take a picture or not. I will come back to this later if needed. So let's talk a bit about Azure IoT solutions. So it's the software as a service offerings of Microsoft, where you take in something that is pre-built and do some modification. It allows you to start very quickly, but you give away some of that control. So before implementing a software as a service, it's important to think about certain things. So keep in mind that when buying or implementing a software as a service, that offering should be extensible. So an offering will never cover 100% of your business needs, of your requirements, so you need to have some extensibility points. For example, you need to have APIs to interact with. You need to be able to export your data, or in worst case, even allow to access your own data. Also, as already mentioned, look at the offering. In what extent does this offering cover your business case, and how much of that business case do you need to implement yourself? And of course, the roadmap, is this product moving fast, or is it really slow? And to what extent can you influence that own roadmap? So these are all important things to consider. So, first of all, let's talk a bit about IoT solution accelerators. There's currently 3 or 4 offerings. So there's the remote monitoring, predictive maintenance, connected factory, and device simulator offering. These are open source reference implementations of Microsoft that are available on, let me hold that. These are available on GitHub. You can download them, you can deploy them to your environment, and basically start tweaking them around to build your own solution if necessary. So how is the main concept of that IoT solution accelerators? They all work the same way. So you have your devices. These are mostly done through C# simulators, but of course you can configure and connect your own devices. You have your ingestion point, IoT hub, some PaaS services, and then you have your microservices that are doing the processing of the data. And then there's Logic App that Rick will tell you all about tomorrow that will integrate with backend systems and processes. So let's take a closer look at the remote monitoring solution. It's been built, it's been set up, the same thing like the reference architecture. So on the left-hand side, you have your simulators. It provides device connectivity. Then in the middle tier, you have your microservices processing, and then you have your presentation layer. So what is interesting in the remote monitoring solution, it has a built-in rule engine. So, and I've been involved in quite some IoT projects, and every project wants to have some sort of rule engine. So what you can do, because the remote monitoring solution is open source, you can go to GitHub and take the pieces that are important for you as a rule engine. So you can take that piece of software, deploy it in your own solution, and then use it accordingly. So I took some time to prepare a demo. So the setup is very simple. So I have created an IoT hub. What I did is I took the Stream Analytics query that is open source on GitHub. I deployed it into my own solution. What it does is it reads a set of pre-configured rules from blob storage, and then it outputs the alerts to blob storage, but I changed that a bit. I will output the alerts to a service bus, I will have a logic app listening on that and posting alerts to Slack. So let me walk you through that demo. So let me first of all, yeah, there was a polar bear. I will come back to that one. So let me first of all show you the IoT Solution Accelerator. So if you go to azure-iot-solutions.com/accelerators, you log in, you have the opportunity to deploy one of those solution accelerators. So for the remote monitoring, if we click on that, you can, I think there's even a small demo here. There's an interactive demo that not, okay, so begin demo. As you can see, you can click it through, see how that demo looks like, and then basically take it from there. So let's get back to that demo I was talking about. So I will start up a simulator. So I have configured the rule engine to trigger any alert when the temperature is over 20 and the humidity is over 60. So that should be, yes, thank you. So as you can see, I'm already receiving alerts inside my Slack. So I'm receiving notifications. And if I open that Slack window, you will see here that there's some alert received from that simulator. So to show you how that works, as already said, very simple. I have configured an IoT hub. Let me zoom in a bit. Is this visible in the back? Okay. So I've created an IoT hub. I have a device there, just very simple. What I did, I took the connection string, used that in my simulator. Then I have streaming analytics jobs configured that has one as an input directly connected to the IoT hub, and then it's reading the rules from blob storage. So if I can show you the rules. So these rules are configured as they are in the open source repository. What I did is only create my own rules and added them to this JSON file. So as you can see, it's not super pretty, but it does the job. As you can see, I'm checking the aggregates of the temperature if it's larger than 20 or than 60. What is very nice and cool, by default, it allows you to define some aggregation windows. So there's instant. So when this rule triggers, it will immediately fire an alert. Then by default, you also have a sliding window of 5 minutes and then of 10 minutes. So this is all taken from GitHub, deployed in my own solution, did some tweaking, and then basically you have a mini rule engine. What can be done better? For example, you can take this JSON file, because that's not super user-friendly. You can put that in a database, create an API on top of that, and so let users create their own rules. So, but it's doing the job. So back to the slides. The next thing I want to talk about is IoT Central. IoT Central is the software as a service solution from Microsoft that is receiving more and more traction within Microsoft as your go-to service for IoT. There has been a lot of investments in this product, and it will receive a lot of investments in the future. It has possibility to connect your devices. They recently made it possible for you to connect edge devices. It has ingestion, command and control. It has rules and actions on data. You can have role-based access control. And what is very nice, recently they also added templating, white labeling, multi-tenancy, and more investments have been made to make this product extensible. As already mentioned, having extensibility in your software as a service implementation or inside your software as a service program is very important. For example, I believe until a year ago, you were not even able to get your own data from IoT Central. So that was really ridiculous, if I can say that. So how does IoT Central work? It's of course built on the Azure infrastructure. It has a UI and it's using security, role-based access control built-in from the ground. So let me show you IoT Central, and now the tricky part will start because I'm working with devices here. So let's pray that these demos go well. So if you go to apps.iotcentral.com, you log in and you will be able to see all your apps that you have configured for IoT Central. So if you want, if you go to My Apps, you can create a new application. And what has been nice is they recently added some templates in there, which allows you, again, to start much quicker. They have solutions for retail, energy, government, and healthcare. So maybe let's do something for energy. So smart meter monitoring. So you can basically go into IoT Central and start creating that application from the start. So let me just show you how easy it is. So I'm just filled in my Azure subscription, give it a really awesome name, and then create. So this will now provision my application. It will take 2 or 3 seconds before that application is created, and then basically I can jump into IoT Central and start building that IoT solution from the ground up. So it's taking a lot more than 2 seconds, so it took 10. So basically now you're inside your own application and you can start tweaking around with this. So, and if we would wait for a couple of minutes, you would see that, that these values would start refreshing. You would see simulated data coming in to show you the value of that application. So let's go back to the apps. If all goes well, I should have an Igloo app here. Yes. Let's click it. So, tricky part. Say hi. Not yet. So I have here an MX chip. I hope this is visible. So this is sending data towards my IoT Central application. So this was created very simply out of the box. So if let me just press this B button a couple of times. So if I'm lucky and the data is pushed very fast, we should see something popping up in this device. So let me come back to that one later. So how does IoT Central work is you usually start with a device template. And a device template allows you to define what measurements your device is transmitting. You can also you're also allowed to set some of these settings. You can see these settings as a sort of your digital twin of your device. So for example, here, the fan speed of this MX chip is synchronized with my IoT Central application through these settings. You can also define some properties. These are just these are cloud owned, so these are just some configuration values of your device. And then of course you can set some commands and other things. So if I now go to my device, so I have, when you create a device template, you have, first of all, you always get a simulated device. This simulated device allows you to, I need to zoom. This simulated device, this simulated device allows you to directly work with the device. It will simulate the values you have provided and allows you to start creating your application without having some real devices connected. So the next thing is, once you have everything configured for your device, you can start creating your own device. I've connected this MX chip is connected with, okay, are you there? Yes. So this MX chip is connected with my IoT Central. For example, if I would change the fan speed settings to 99, you would see that it receives that update, and if all goes well, you would see something moving on that device. It will update the fan speed, and this is synchronized automatically if you have created your device template well. So another thing, as already mentioned, extensibility is super important. So this data export allows you to export all the data that's in IoT Central to your own endpoint of your choice. For example, you can export all your data to Blob, Event Hubs, and Service Bus. So this basically means you can leverage everything from IoT Central. If there's something missing that is not covering your business case, you can create these extensibility points and take it from there. Of course, there's also some other features, like you can customize your application, you can white label it, choose your own colors. What is also fairly new is this one. So what you can do here is create an application, build your own template, and export that template. And then what you can do is you can basically start creating a new application from that template. So this allows you, again, to think more in an enterprise way of using IoT Central. So it's interesting how fast this product is moving. So it's, to my opinion, it's definitely one to watch. So that's it. More rabbits. So let's talk about, we had the software as a service offering. So let's talk a bit on the PaaS services, how to build your own IoT solution, what to take into account, and what go-to services you definitely need to think about. So there's a couple of important things to think about before implementing an IoT platform. So basically, key features that your IoT platform will need, or that you will need to build, or need to do before you can say that you're having an IoT platform. So first of all, you need to think about connectivity and device management. So how will you manage your devices? How will you manage the entire life cycle of your devices? How will you connect devices to your IoT solutions? It's very simple to connect greenfield devices that can talk to the internet, so you can connect them directly to IoT Hub. But what with devices that talk some kind of weird protocol, or devices that simply aren't allowed to connect to the internet? So how will you tackle that? So you need flexible and multi-tenant logic. So an IoT platform or a cloud solution in general is constantly moving and evolving. So you need to be able to, your business logic needs to be able to be, to quickly deploy, to change, to be flexible, and to make sure that you're iterating fast in your platform. You want to have cross-tenant insights. So IoT, if you remember the general slide of Microsoft, it's your things, your insights, and your actions, something like that. So it's important to create those insights when you do an IoT project. So, and if you have a multi-tenant solution, you also, as a builder of the platform, you want to have those insights across all your tenants. And then, of course, you need integration and flexibility. You need to interact with other software that your company is having or that the customer is having. You need to talk with other platforms. You need to talk with the ERP and so on. So, and there's a whole range of services available on Azure to support these things for you. Unfortunately, there's no time to go through them all. But I will talk about a couple of the most important services when regarding to IoT. So I will talk about IoT Hub and device provisioning service, and a service that I really like a lot is time series insights. So IoT Hub, as already said, it's your main entry point to the cloud, together with IoT Edge, of course. It has support for millions of devices. You can send commands, you can do device management, you can do message routing, and so on and so on. It also has quite some security features that allow you to make sure that the connectivity of your devices to the cloud are done in a secure way. So there's a couple of, I'm mentioning here IoT Hub scenarios, but this is more like IoT scenarios in general, how you can leverage IoT Hub to go from your devices towards your end solution. The first one is super easy. You have your device is able to talk AMQP, MQTT, or HTTPS, then you're good to go, and you can connect directly to IoT Hub. This is the most easiest case, so this is super cool. Next one is when your devices are not able to connect directly to IoT Hub, you can consider using a field gateway. A field gateway is a device or something deployed in the field close to the devices that will be responsible for connecting devices. It will take in the data, forward it to IoT Hub. So the thing there is you want to think about, inside IoT Hub, what identity will you talk to or do you want to see? Do you want to see your end devices or only your field gateway? If I'm not mistaken, Martin will also talk a bit on that later, no, tomorrow, sorry. No pressure. Next one is when you have custom protocols and those protocols are able to connect to the internet, you can choose to have your cloud gateway, basically deploying a gateway in the cloud and then making sure that cloud gateway drops everything to IoT Hub. And another, I think this is the most complex setup, is you having a field gateway connecting with your cloud gateway over VPN or express route, where your field gateway is also not able to talk one of those IoT Hub protocols, but is talking OPC, CoAP, and so on. Yeah. So, and once you are in the cloud, you can start creating your management apps to manage your devices, start building some business logic on top of that, and basically create your end-to-end scenario. So there's some key features in IoT Hub that are used or that you should consider for enterprise IoT solutions. First of all, there's the message processing, the routing. Of course, you have device management, jobs and queries, and message enrichments. So the last one, the message enrichments, is a feature that has been added recently, which allows you to basically enrich messages as they come in. But I'm having a demo on that later on. So first of all, message processing. So your device will send messages to the cloud. There's inside IoT Hub, there's device to cloud endpoint, which is responsible for taking in all the messages and sending them towards your event processing hub path. The other way around, with Cloud SDKs, you can trigger some logic on the device and basically send feedback from your cloud to your devices, and that is called cloud-to-device endpoints. Message routing is a feature that is very useful to do some as it said, routing on the messages before doing any business implementation. So how that works is you can create custom endpoints in IoT Hub, event hubs, service bus, storage. So you can create those custom endpoints and then create a set of rules, a set of queries that will query over your data as it comes in and basically dispatches it to the correct endpoint. One downside of this is if you want to query on the body, your body needs to be in JSON, which is somewhat painful if you're not sending any JSON. What would be nice as an addition of IoT Hub is a sort of decoding step before this routing actually happens, so that you can decode part of that body, then let it route, and then you can do it. So that would be one of a nice add-on onto IoT Hub. So message enrichment works a bit similar, but what it does is when a message comes in, it allows you to add certain things to that message to enrich that message with data that you want. For example, in my case, in my demo, I have 2 MX chips that are sending temperature and humidity, but they are not able to transmit their own device ID. They don't have any device ID. So what I did in IoT Hub, or what I will do later during the demo, is I will enrich data coming from these MX chips with things that I configured to be able to distinguish the messages coming from the 2 devices. Of course, there's device management, which gives you a device twin, which you can synchronize your properties, your tags. This is mainly for making sure that settings of the device are in sync. You can give your device tags, so you can group them. For example, if you have different sites, you can group them accordingly. Then what you can do also is you can invoke direct methods onto your device, so which basically means you're exposing a method onto your device, making sure that IoT Hub can call in directly into that method and, for example, allows you to reboot that device or, let us say, install new firmware or something like that. So jobs and queries allows you to query over your IoT Hub devices. This is for reporting, for business logic, for mass updating, and so on. jobs is similar, so you can schedule device twin changes and so on. So the device provisioning service, it allows you to plug and play provisioning. How it works is that you upload a set of devices or configurations to the device provisioning service. You configure that device provisioning service with a set of IoT hubs. And based on certain rules and logics that you define, there are some built-in rules and logics, but there's also the possibility that you create your own function so that you are in full control of that, that assignment process. Based on that rules and that logic, DPS will basically tell to your device, go and connect to that IoT hub. So this gives a lot of flexibility when your IoT solution is deployed basically across the globe. So as already said, it has support for all devices. Again, support is being worked on for edge devices. It's already there, but it's still a bit tricky sometimes. So what is new here is it allows, currently the new update of this allows you to define a certain set of data that will be added to your device when it's being provisioned. So time series insights is your time series data source, which is built for IoT. You can query your data. It has warm storage built in. So what it does is when you ingest data in it, it basically stores it into its warm storage, and it allows you to have sub-second queries of your recent data. It also has cold storage. What it does, it basically offloads the data to more colder storage, so you can query also that data, but it will take you some more time. And you could even bring your own data if you want it to be queried in this data store. I will show you the different feeling of having that sub-second query and that multi-second query difference of warm and cold storage. The thing is with time series insights, it's a PaaS solution. So you can go to the time series insight portal, start building your queries. But what you also can do is query directly the API. There's also JavaScript libraries available, which you just can extract the dashboards and bring them into your own solution. So for example, if you're building this for a customer so that you don't have to give access to the customer to time series insights, you can basically extract some of these dashboards and basically embed them in your own solution. So let's go through some demos. Let me see if this thing will still work. Oh, no. Demos first. So first of all, I'm going to guide you a bit around IoT Hub. So let me first take this one. So IoT Hub, what I did is I created an IoT Hub with 2 devices, 2 MX chips that are connected over here. If all goes well, you should see some of the metrics. So the devices are actually still transmitting, I hope. No. So the devices are transmitting messages. Let me just plug this one out and plug it back in. Hope this one will work. So you can see the metrics over here. So as already mentioned during the start, there was a problem with these MX chips that they only sent temperature and humidity. What I did, I've added a tag on both of the devices, specifying, okay, this device ID is now my MX chip 001. What I will do is I will leverage the message enrichment, the new feature of IoT Hub, and inject this device ID into the message, so I'm able to route this message further down to my IoT solution. So let me just clear this, clear output. So let me stop monitoring. So Visual Studio Code has some very neat plugins for IoT Hub, basically allowing to monitor your incoming messages, to send commands to the device, and so on. So if I'm now start monitoring this, there should be some message coming in, but I'm seeing here that that's not working anymore, so let's go to the backup plan, which is also very nice to show. So this is, if you're not aware, there's an MX chip IoT simulator for speakers who are doing some talks with the MX chip, and the MX chip is dying. They can go to this website and demonstrate the workings of the MX chip. So if all goes well, and I start running this now, I should see some messages coming in. Now, yes, as you can see, that actually is that simulator is sending device IDs, but I will make something out of it. So you have your temperature, humidity, and everything else that is transmitting over there. So let me stop this. Let's go to the message routing, and that message routing allows me to, first of all, if you remember, you can define custom endpoints there and your routes, but what I'm interested in this demo is the message enrichment. So this message enrichment allows you to enrich messages as they come in into your IoT Hub. Small downside here, this is configured on IoT Hub level, so there's no fine-grained enrichment possible on a device. So let me open this cheat thingy. So what I will do is I will inject the device ID from the tags with this value, and I will inject it as the message come in. I will just call it Igloo device ID for now. What you also can do, and of course you need to select your endpoint. What you also can do is do some fixed values, insertion, and so on. So if I click apply, I always forget to select the endpoint. So I can apply this one here. So this message enrichment is now being applied. And if all goes well, let me clear the output again. It's saving, yes. And if I start that simulator again, if I click run, you should see something popping in regarding these message enrichment that I've done. Is it? Yes, it's over there. So the Igloo device ID has been added, and the hello world is also there, and this is done with the message enrichments. Let me quickly show, because I'm running out of time. So quickly show you Security Center for IoT. Sorry for rushing this a bit. So this can be enabled onto your IoT hub, and it will give you some recommendations regarding your devices. Unfortunately, my devices did not receive any attacks during the setup. So, but if your devices would be attacked or there's something wrong with your devices, these things would starting to pop up. So let's quickly go to time series insights. So before going to time series insights, what I did is I'm using an API. So let me take it back. So what I did is I configured this demo, I think, end of November, beginning of December. And what I did was I've set up an ingestion of data that will query the weather data of Brussels and the weather data of Helsinki and insert into time series insights. So I was hoping to get something out of it, but let's see what it gives. So what I'm using is, I briefly want to mention that, it's the Dark Sky API. It sounds, ooh, but it's an open source API which allows you to query all the weather data you want. And I believe you have 1,000 calls for free a day. So that's really nice. So I've been using this API since November and basically paid nothing. Thank you, Dark Sky. So how this one works is very simple. You need to give the coordinates, and then you basically get all the data back. So you get the current temperature, you get the minute version. You can even, if there are alerts in your neighborhood, for example, if it would snow in Helsinki, apparently it doesn't snow anymore. So you would see this over here. I think I can show you it if I go down. So you have minutely, hourly combinations. So it's huge, actually. So here you get the alerts. So it's a really cool API to use. So I would say if you want some real-time data to play around with, this one is definitely one to watch. So what I simply did, and Rick will kill me for this setup probably, having a recurrence. I'm also very good at naming conventions. So I'm doing recurrence, doing 2 HTTP calls to the API and just sending them to event hubs. Sorry, Rick. You will tell everything what's wrong about this tomorrow, right? No? Okay. So it's ingesting the weather data. So let's go to the time series insights environment. Faster. So first of all, when creating or using time series insights, you can define hierarchies. What I did here was define my cities of Brussels. And then as you can see data coming in, you will be able to assign data streams that are entering in time series insights to the correct instance of your hierarchy. So that's based, in my case, I'm defining this hierarchy automatically based on the name of the city that's inside the message. So he's building that hierarchy himself. So if we now go through the dashboard, so let me go back to starting of December, not taking in the first 15 minutes because I did something wrong over there. So I'm now going to show you the temperature and the apparent temperature for both Helsinki and Brussels. Let's make this a bit prettier. So this is all the weather data since beginning of December. I've tried getting something useful out of it. The only thing I noticed is that if you add some markers to this data, is that the apparent temperature, so the temperature that you're feeling in Helsinki, is always much lower than the feeling you have in Brussels. So apparently it's always cold here, but it's actually not, or something like that. Yeah, that's it. You think it's cold, but actually it's not. So what you can do here is you can also explore your raw events. So, and these raw events are what, as the wording says, your raw events that are coming in time series insights. So these will load the most recent values from your hot storage, but if you want, you can load more, and this one will now go to your cold storage and load every event that has passed since beginning of December and load it into the event store. So as you can see, this is a bit longer than it used to be. So you can download all this data as CSV file, you can export these to Power BI, and so on. So let me quickly jump to the slides, because I only have 5 minutes left. So, briefly mentioning the Azure IoT reference architecture, you can find this on this URL. It's the reference architecture of Microsoft that is basically having a guide on how to build cloud-native IoT solutions. So edge and device support. So having edge or cloud capabilities on your edge is really key when it comes to real life or production grade IoT scenarios. I haven't really come across an IoT solution that didn't need any of the edge capabilities that Microsoft is offering. But Martin will cover for me on this, because I'm running out of time. So briefly talking IoT pattern, what edge does is basically taking those insights and actions back to your device and doing that local processing and insights and actions for you. So more on this tomorrow. Be sure to watch this guy giving an awesome talk. Yeah, I always wanted, it's that Martin, not the other one. So the road ahead will all be about having that IoT solution interacting with your people, your places and devices. So the focus will no longer be on these things, but will more be about the people and the experience that people are getting from your IoT solution. And that's why I briefly wanted to mention Azure Digital Twins, that is currently still in preview, which is leveraging everything regarding Azure IoT, and will make sure that you will be able to... it's my cue to stop talking, probably. It will allow you to model all the experiences, the relationship between your devices, your space, and your people. So as already mentioned during the start, as a recap, there is no wrong or right when choosing for software as a service or implementing the IoT solution on your own. The thing is, the most important thing there is you want to make sure that you're doing it as you want, you're covering your business case, and be aware, if you're using software as a service, you gave away a bit of your control, but when you're implementing it in the past, you have full control of your own, but the downside of that is that you are responsible for all the side things like scaling and so on and so on. With that said, thank you for listening. I see that guy is already smiling. I'm perfectly on time. So if there are no any questions, I would like to thank you. Come and find me if you do have questions. So thank you for listening.
Excellent. Thanks, Glenn. All right, let's have a 15-minute break before Tom tells us about API management. 15 minutes. Thanks, guys.
magical unicorn. Yeah, exactly. Who gives a shit?
All right, all right, all right, all right. You got coffee? You are woken up, all the words. Cool. So the next talk has everything. It has the API management, it has microservices, it has hybrid, it has the cloud.
Ding, ding, ding.
Yeah, it's a moneymaker, clearly. So let's welcome Tom.
Thank you. Okay, good morning. So indeed, I will talk about API management in a microservices world where you can run in hybrid scenarios or multi-cloud scenarios. So my name is Tom Kerkhoven. I'm an Azure architect at Codit. You can find most of the demo on GitHub. If you can't find it, you can also ping me on Twitter. And I'll start with a small disclaimer. So I'm filling in for a speaker who couldn't make it, which is maybe good news. I'll let that up to you to decide. But the sad part is I deleted all my demos 2 weeks before that. So I have a small backup demo. It's not ideal, but I hope it still proves the point. So we'll go ahead. So in this talk, I'll use the fictitious company Codito, which decided to build a API platform for their customers, which allows them to list all the products. Customers can create orders, and then those orders are automatically shipped to all the customers. And to do the shipments, they decided to work with a third party who basically also integrates with their platform. Okay, so we have a couple of APIs, we have webhooks, etc. So in their initial days, they decided to create a small MVP, which is just an Azure web app, which has all the basically APIs in one physical API. So this was perfect because they decided to start small, build an MVP, get the product out the door, start building a customer base, start to get some money, and the third parties were able to start integrating with them. Now the problem is that if they want to fully secure that API, every customer also has to basically implement that security. So if they decide to use client certificate authentication, every client has to do that as well, which means that mobile apps, etc., also have to go through that pain. It's not ideal. Application developers also have not very ideal experience, and there was no governance nor analytics on the API for Codito. So they were looking for a better way to do this. That's why they decided to go with Azure API management. So basically, it's a facade which they will use to expose their services to the customer, and that allows them to simplify the authentication on the client side, but internally they can be as secure as they want. Basically, they can have mutual TLS, they can have VNets, whatever, but the consumers are not impacted. Another benefit is that it comes with a developer portal. So basically all their clients can basically browse the whole API in an interactive way. They get API analytics on a per customer basis, so they know who's doing what, and they can basically go and speak to them if they're an abusive user or not. So basically they're creating a whole central API hub for their application, which is no longer leaking the internal implementation details. So basically it looks like this. So on the left we have the developers who can use the developer portal, and our third party is just sending all their webhooks to the gateway, and in the backend API management is just forwarding all the traffic to the same web API. So they didn't have to change that. And as Codito, they can manage the whole gateway via the management API or the management portal. So we have now split the customer from our internal system, and they have all the analytics, etc. So their platform starts to evolve. In terms of API management, they have started with a very simple approach. They have one product which the customers can use, and that one product just has one API, which basically is what they already had. Okay, a product is typically a collection of multiple APIs. In this case, they just have one. but a product you can see as a way where customers can get a subscription and then they have access to everything in that product. Now this is ideal, but basically they started growing very quickly. They have a lot more traffic. They want to add more developers to basically add more features to the platform, so they want to go really quickly. And their MVP is basically transforming more in a product. So they want to do things really good now. Now the problem is that the monolith is also very hard to scale. They have to scale the whole big block as one chunk. So if the third party is sending a lot of webhooks, they will basically scale out the whole application rather than just the shipment part. Releases are also very hard because they have to release everything as one big block. So if there's an issue in the shipment part, it will also impact all the other parts. So they decided to look for an alternative, and somebody said, hey, let's use microservices. Then the other guy said, micro what? What's that? So microservices are basically a way where you can split one monolith into a lot of smaller chunks so that you can basically focus on one service in your total landscape. So in our case, we will split the monolith into a product service, an order service, and a shipment service, so that they can basically do individual releases to every part, they can scale every single part, and they can use a certain tech stack depending on the needs. So for example, if you want to do data-related operations, Python might be better than .NET Core, for example. Now, if they do microservices, that means that they have to change their internal system. And that's not really an easy thing to do, because if they do that, it comes with a lot of complexity and risk, because they want to make sure that their current customers are not impacted. And because they want to be future-proof, they've also decided to go with containers, because then they have smaller services to run everywhere, basically. And if you hear containers, most of people say, hey, let's run on Kubernetes. That's not what they will do. They will start with a PaaS approach, which basically gives them the same management capabilities, but all the rest is managed by Microsoft. And that's what Azure Web Apps for Containers do. It's basically web apps, but instead of a zip folder, it's just a container. It's the same way of scaling, same way of configuring it, and etc., but it's with a container. Now, because they use a container and web apps for containers, that doesn't mean that they can go to Kubernetes over time, but because they don't need that complexity, they're not doing it yet. Now, that's all nice, but how do we really get there in practice? So that's where an API gateway also helps a lot. So we had this before, and they will start with the logical separation, where they will add a logical API in the gateway first, so that the customers can already see these new APIs. That's important because eventually they will have to deprecate the Codito API, because they don't want to maintain that forever. By allowing them to already use the new logical APIs, all the customers can already move over. You can already put an end date on the deprecation, and they can start doing the changes on their end. While in the back end, we're still calling the same old monolith. Okay, that's the first step. So that's a breaking change on the customer end. Eventually, you'll have a breaking change somewhere. So it's the best way to do it on the gateway itself. Now, once you've done this logical API change, internally you can do whatever you want, because the customer will not see this. Okay, so the logical APIs are a good way to basically give a componentized way of your platform. So taking a step back, we still have one Codito product which has all of these logical APIs. So the customers will have one API key, and they will have access to all of these logical APIs. Okay, think in terms of having a Twilio account, which is the product, and in the Twilio account you will be able to send SMSs, make phone calls, etc. Okay, it's a bit the same. And when new customers on board, they can already use the new approach. They don't have to go to the legacy. Okay. Now, we still have to route the traffic accordingly. So if they're still using the old logical API, we have to send it to the new container way. And that's actually how we will do it. So we will use AB traffic, basically, and if they're calling the legacy API, we'll basically route half of the traffic to the monolith and half of the traffic to the new web apps for containers, basically. That's an easy way to basically see if their new containerized approach works, because containers are new for them. Web apps for containers are new for them, so they want to verify first if it works before they make the full switch. And as part of this exercise, the shipment team also decided that, hey, our webhooks will route to an Azure function, because it's a very lightweight thing to do. But because we split our monolith from one in-process API to multiple services, the order API also has to call the shipment service internally, and we have a second service. While in the past, this was all in process. Now it's an additional HTTP call. So the function is for the external webhooks, and the web app is for the order API, which basically triggers a new shipment and calls then the third party. Long story short, with API management, we can basically do 50-50 trafficking between two endpoints and basically verify that the new approach works. So I will quickly show this. Is this big enough? Yeah. So what do I have? I have one research group here, which is API management. And as you can see, I have an availability test in there. So basically, I'm calling, in this case, it's not Coolitool, but it's a bacon API, which just lists 3 flavors of bacon. It's all I had. So that's being called from 15 locations across the world. And you can see that basically API management is now calling the Iglooconf 2020 serverless. Yeah, it's a bit small, but we're calling that endpoint, which is the initial monolith, which in this case ran on Azure Functions, which was, it's published from Visual Studio. You won't see the code. Basically, it's just one function, get bacon, and it's returning a list. Now, in this example, we'll move away from a function to a web app because we want to have more control. In the scenario, it would be from a web app to a web app for container, but the practice is still the same. So if I go to API management, you will see that I just have the bacon API over here. And we will basically apply a policy. Now, we already have a policy in place, which basically adds my Azure function key. You can steal it. I will delete the resources anyway. But at the end, we will also add some headers so that we get some insights on what was called for the sake of the demo. So if I will do let me see if I can make it bigger. No. Oh, wow. So you can see that I get a slab bacon, Canadian bacon, and smoked bacon. And in the headers, you can see that the runtime was called is serverless. But I really need to zoom this thing. How do you do that? Okay, here. Zoom in. Yeah, that's better. Can you read it? Yes. So you can see here, we added the X runtime header, and we called the serverless one, we called the gateway and West Europe, and that's it. Now we want to switch that instead of calling the Azure function, we call our web app for container. And you can see that here because there's a container setting here. And it's just pointing to a Docker image on Docker Hub. Basically, instead of the Azure function, we will call this. Why is it not showing the URL? We will just call this URL, which is -pass instead of serverless. Now I have a policy for this. And it's based on one that is in the example repo. And for those who do not know, let me open it up. There is a GitHub repo by the Azure API management team, which basically has a whole set of policy snippets which help you get started with API management. There's a lot of stuff in there, adding correlation, doing what we're doing now, adding authentication, other stuff. Basically, if you're new to API management, this is a good resource to learn how to do things. So in this case, we need to split the traffic in half. Now, API management doesn't have anything out of the box for this, so we'll use a very rough approach by just creating a random number between 1 and 10. And if it's below or equal to 5, then it's the first partition, and otherwise it's the second partition. So basically here we generate, it's between 1 and 3, sorry, the URL ID, and then we check if the URL ID is 1, then we call the same Azure function. If it's not, then we call the new PASI approach. And at the end, we basically change the header and the response so that if it was 1, we specify, let me change this to serverless. And otherwise, we return experiment, which in our case is in Azure, is app services with containers. Any questions on this before I run this? It's not really rocket science, but it works. So now it's being deployed on the gateway. So if I now start calling it, you will see that it will start switching. So now it's still called the serverless one. Now you saw that it's calling the experiment. And we see that the body is also the same. So in theory, you can say that our experiment works. So in the real world, you will not test this for 5 minutes. You would keep this up and running for a couple of days to weeks, see how it goes, learn how to run containers on web apps, and then fully switch all the traffic to the new destination. Okay. It's a very, as I said, it's a basic version of the demo, but that's the whole idea. So in the end, once you've decided that the container approach works and you want to kill the monolith, basically you'll end up with this approach where the products API forwards to the products API on the web app. But that means that we still have the legacy Codito API. And over there, we have to add some routing as well. So we would have to check the URI path. If it's API/v1/products, then we have to call the products API on the web app and otherwise the other one. So you still have to maintain them. But again, policies are a great way to do that. Basically, they allow you to run some edge logic, let's say, to route your traffic. So basically, you're a bit implementing application routing in API management. Those who are familiar with Azure Front Door will also know that this is possible. They are similar, but they are also different. Whereas that if you would use Azure Front Door, you would typically put it in front of API management because Front Door uses the points of presence across the whole world. Where API management is a regional resource, so that's different. You can combine them, but if you do already the application routing in front door, keep in mind that you still have the API keys in API management so that they have to route to the correct instance. Okay. Codito is a really successful product, and then I think we all know the customers who then say, hey, that's great, but we can only run on-prem, which is a fair statement, but that's not easy, certainly not in a cloud-native world. But with API management, they basically fixed this in the sense that before Ignite, this was the typical API management scenario where all traffic was first going to the API gateway. And then in API management, they saw, I need to call this URL, so then I forward it to the corresponding physical API. Now, they introduced Arc-enabled API management, which is a mouthful, but basically it's a self-hosted version of Azure API management, which you can practically run anywhere, be it on your laptop, on-prem, on another cloud, or on Azure Stack. It's the same version of the gateway, but you can basically run it where you need to. Now, that also comes with a consequence. If you have to run it, you have to scale it, you have to patch it, you have to monitor it, etc. Now, it's good to know that it's managed from the cloud, which means that while the gateway is running practically everywhere, you have to still configure it via the Azure portal, and every gateway has to have an outbound connection to Azure, because basically it pulls all the configuration from API management, which is a storage account, I think, behind the scenes. And basically, that's how it's being updated. It can run offline. It's still in preview, but now it can run offline, I think, forever. I'm not sure if that will stay like it, but it's not that it needs to have a permanent internet connection. Now, it allows you to have a consistent API experience. So this changes in a way that you can basically take the gateway and run it in a Kubernetes cluster. I know Martin will be very happy with that. You can run it on Docker Swarm or just on your laptop or anywhere. And then basically you can call, so then it's federated to the master API management instance, and then you can basically call your nearest API gateway. Yeah, you can also run it in AKS as well, but I will quickly show you this. So we now have a Bacon API in the cloud, running on a web app on the API management instance managed by Azure. What we will do now is run one on-prem, which in this case is my laptop, and then call a local containerized version of the Bacon API. Okay. So, since the preview, there is a new section here, which is called Gateways Preview. And I have a Santa gateway. Actually, let me show you how you can add one. It's very simple. You give it a name and the region is a logical region for you. You can basically give it any name, which makes sense to your application. So, in this case, I called it the Santa gateway, which is located in Finland, because that's where he lives, depending on who you ask, but that's where he lives. And it's good to know that you already out of the box, you get the same metrics as the API management gateway. Okay? It's very important. Typical previews would not think about metrics until it's shipped to GA. They have it from day one. Deploying is very easy. They basically have to have a configuration file which points to the master endpoint and an authentication key. They have an example for Docker, and they also have one for Kubernetes, which is a deployment YAML. But if you go to helmhub.sh and you search for API management, you will see that I created a small Helm chart for this, so you can just do Helm install Azure API management gateway, and it's running in your cluster. So in this case, we'll just use the Docker way, and I will actually, I will go to my local configuration here. So it's just the same thing that was in the Azure portal. And what I have now is a Docker Compose file, which basically has my Bacon API. It has the new Azure API Management custom API documentation, and the gateway. And here I just say that for the API Management gateway, it needs to load the API gateway config file as an environment file. So if I do a Docker compose up, you'll see that it starts all the containers. And I'll go here. So you can see here that we are up and running. So when I want to show you quickly, it's not the core of the talk, but as of today, well, as of end of last year, the new developer portal is GA, so it's just a static website, which means that you can also containerize it and run it the same way as your other applications. So you can also run it locally. But in our case, we are going to use this local API Management gateway. Okay, let me quickly go to the logs of that one. Basically here, if I would do a follow, you can see all of the things that happen with that API. Now, not every API is automatically added to all of the self-hosted gateways. So basically what I did here was I said, hey, on this gateway, the Bacon API should be available, which also allows you to segment the APIs that are exposed on that location. Now, if I call this API, it's going to call the local Azure API Management Gateway, which just returns me the same information. You will see in the headers that it's still called the experiment with this upstream URL. Okay? The reason is I didn't change anything in Azure API Management, so it doesn't know that there's a local gateway as well. So again, we need to do some application traffic routing. And for that, I have another policy. So in this scenario, we've assumed that we've stepped away from the experiment worked, and we just have a check, hey, in the context of the request, which gateway was called and what is the region of its deployment. So in my scenario, I called my gateway Finland, so we'll use that as a traffic router, while if I would call the one in Azure, it would be called West Europe. So just as an example, in this URL, you can already see that the gateway region was Finland, while with the Azure-hosted one, it was West Europe. So that's a way of splitting our traffic. So now you will see how Azure is updating its gateways. So, too far. I need to go to... So I will apply the policy. Oops. And note here that the name that I use here is the name of the Docker container, so that the gateway can use the Docker DNS to discover the container. So now that that's deployed, let me maybe quickly show you the logs. So you see that here a new event was read, and that it basically saw that this API was updated. So it basically pulled down the whole configuration and applied it locally. So that if I start calling it now, you will see that my upstream URL is now the Docker container, and the region is also Finland, while if I call the cloud-based one, you will see that it calls the function which was the default URL. Okay? So that's how you can basically do the traffic split. It's a bit clunky if you ask me. It works for now, but I'm pretty sure this will be improved. It's still in preview. But for the customers that we have, this is very important because we, for cloud-based projects, we always use Azure API Management, but on-prem we used another product because it was not possible. But now we can basically use the same technology. And if the customer is ready to go to the cloud, they can just reuse the same technology and they don't have to relearn that tool chain. Now another nice thing is that because they have telemetry out of the box, you can already see, maybe I should make it a bit bigger, see that the application insights integration is also surfacing my local Finland gateway, which called the web app here. And okay, it's already there. So now as a second part, no, it's not there yet. So if we wait a couple of more minutes, we would see our container also in this overview. So this also helps you show you all the traffic with your policies, which is very important for your operational people. One more try. Okay, I won't wait because I only have half an hour. Okay. Now, Azure Arc is a great way to basically have the same experience wherever the customer is. Now, it's a fictitious scenario, but there are a couple of lessons learned that I've seen at different customers who are doing similar things, which is you should always build a monolith first, in my opinion. Go to market, start to build a customer base, and also get to know your product more from a business domain, how it should really work functionally before spending too much time on the technical details and making it too complicated. Well, you don't need it, basically. And this is a nice overview of Martin Fowler. So if you really want to go to microservices from day one, you can battle the dragons, or you can just start small with a monolith and move the microservices out piece by piece once you know the business domain. Because if you go to microservices first, you will certainly get your business domain wrong, and then you have to redo it anyway. That's not what you want. So building platforms is really a journey. You will never end up with the same architecture that you have from day one as you will have in 5 years. Requirements change, customer demands change, your technical stack change, but your underlying infrastructure also changes. Who has ever had to migrate from an Azure service because it was deprecated? Okay, that's fairly few people. That's good. I can assure you the day will come and you will need to hurry, which is not a good thing. And an API gateway in front always helps you with that. And small apps really require little control or complexity, because otherwise you will spend too much time on that rather than the business value. And I was talking to Martin yesterday about Speaker Travel, which is an application he has, where he could start with a lot of containers who are calling each other to build a true microservice, or he could just create one API, which is a web app which just does the job. He can start getting customers and then later on refactor and let it grow, which is a good approach in my opinion. And this is one I like a lot because everybody reads about Kubernetes and service meshes and all of the fancy hip stuff and doing chaos engineering, and while that's all great, you really have to have a high scale and a lot of customers before you're already at that point. You are not Netflix. You should start small, and over time you might need it, but you don't need that from the beginning, which is okay. I always guide my customers to start with a more passy approach, and then over time evolve to things where you have to have more control if you really need it, like Kubernetes. Is Kubernetes bad? No. Does everybody need Kubernetes? No. Everything has its place and time, but you really need to make the trade-offs if you really need it. In this case, for Codito, it reduces the operational overhead, the learning curve, etc. So it didn't make sense. They already knew how to do web apps, so they could just reuse that same tech stack. So they were able to focus on the application, not the infrastructure. But if they have 5,000 customers and a team of 1,000 developers, then it might make sense because they need to have that more scale. So just to show how it can be a journey, we started with an API gateway with one app, which was the monolith. But then we decided to split it into multiple microservices. And the first difference is that instead of one service, we have to operate 3 services. The second difference is that the in-process calls that you could do are now going over the wire, which means that in theory, you should also decouple those and have an API gateway in between. Because what if the shipment service changes? The order service should not be impacted. So basically what you're doing externally should also be done internally. And then if you go to a more container orchestrator way, it's even more complicated because you have to expose your services via ingresses. Inter-service traffic is done via services or service meshes. And then we haven't talked about the whole cluster that you have to manage. So again, everything has its time and place, but it's a lot easier to start with less components than to have an overblown scenario, which you don't need. Okay, the conclusion. Are microservices evil? No. Is a monolith evil? No. But you just have to pick the correct time for it. An API landscape requires, use the API landscape that your platform requires. Don't over-engineer. Again, use a monolith first. And then lastly, an API gateway can really help you because it decouples your application. It gives you insights on how customers are using your application, and you can act accordingly. For example, we had the deprecated logical API, but when do you delete it? If you do not have the telemetry and the analytics to know that nobody is calling it anymore for a month, then you can just guess. Or delete it and see who complains. That's also a way to do it, but I would not do it. It can also act as a protocol gateway. Imagine that you have to expose those legacy SOAP services. API management, for example, can translate that to REST so that new clients can already use the new approach. So really don't underestimate an API gateway. And with that, does anybody have any questions? They have to ask one question at least. Martin, you're raising. Yeah, Carl. Oh, DevOps with API management. How long do I have?
A minute.
In my opinion, it's a pain. You can use ARM. You can use scripts. I use a mix. Typically, I use an ARM template to spin up the API management instance and the logical API and products. But to inject your whole Swagger configuration in API management, I use a script which basically takes an open API spec, injects it in the ARM template, then deploys the ARM template, etc. They have a whole Azure DevOps kit for API management, but it's a lot. I think you have to have a master instance, which basically allows you to export a new them, and then, no, it's ridiculous. But I would say scripts and ARM is a good mix. Any other questions? No? Okay, thank you very much.
Excellent, and thank you, Tom, for helping us out.
My pleasure.
So Tom's speech that he prepared, that's tomorrow. So this was just something he had in his back pocket. Also, I think you spoke about something like this in Ignite.
Yes.
Yes, so that's probably in the internet. The Ignite, is it video?
I think so, yeah.
So,
should be on the website.
So if you want to see the demos, Bacon API was cool, but if you want to see the demos he prepared for this stuff, then there's the Ignite video that's probably available. We are, because this was an Ignite 45-minute talk, so we are 15 minutes ahead. Does Nordcloud want to come up and tell the people about the party we are going to have tonight? Or do you want to tell about that later? Is now a good time? If not, it's public shaming. Come on over, sir. Nordcloud.
Hello everyone, I'm Iglooconf working for Nordcloud, and we are hosting this after-work party after today's events, and it's located in our office at Antinkatu 1, which is right next to Kamppi Shopping Center, and we will have food and drinks for you there, so hopefully all of you can attend. And how to get there, so if there's people who are not living in Helsinki, so you can take a tram from there's a tram stop right next to this hotel, and take tram to Lasipalatti, or then you can just walk. It's about 10 to 15 minutes walk from here to there. Then a little bit about Nordcloud. So we are a company focusing on public cloud services, and like everything from a cloud infrastructure to cloud application development and designing, and also trainings. So if you want to know more about us and what we do, so me and all the guys with similar hoodies are more than happy to tell you more about us. Thank you.
So you have enough drinks? Asking for a friend. Cool. All right. The speakers will be there. So feel free to come and bother us and them later today, and I hope many of you make it to Nordcloud so that they can host us a party next year to make a lot of questions to them, so it's a success. All right, what time is it? It's 5:30. Should we have half an hour snack break? All right, guys, half an hour snack break. Woohoo! Snacky snack! See you at 15.
Okay. Welcome back for the last live streamed and recorded session of today before the famous slash infamous panel, which is not recorded and which doesn't leave the room. So last we have our final Dutch-speaking person for the day to complete the set. Yeah, Eldert, I'll let you again introduce yourself.
Thank you. So, thank you everyone for being here. I hope you are all enjoying your day so far. Some very, very good sessions, I thought. So, I'm Eldert Groteboer. I come from the Netherlands, where I work at Motion 10. So, we work with basically everything Azure, every Office 365, but that doesn't really matter now. Today, I'm here to talk about Azure messaging services. So first, let's discuss what is messaging. So messaging is sending type of messages between two systems. So this could be your SAP system, maybe a custom API, maybe something like an Oracle database. You're sending messages between systems. So what we are not talking about today is things like mobile messages. So we're not going to talk about notification hubs, for example. We are also not going to talk about IoT Hub, because that was already mentioned by Glenn, and it will be mentioned again tomorrow by Martin. So what we are going to talk about is the messaging stack, as Microsoft calls it, which consists of 5 different services. And those services, very quickly, are first off storage queues, which are just simple task queues, just very simple queues, put something in, get something out, done. If you want more enterprise messaging, you will be looking at Service Bus. For event-driven messaging, you will be looking at Event Grid, which you already saw a nice session by Sam today. Event hubs for your streaming data. And finally, Relay for hybrid connections. So each of these we will be seeing today. I will talk a bit about, okay, what are they doing, when should you use them, and when shouldn't you use them. So we have these 5 different messaging types of messaging services. And if you take more like IoT Hub and other even notification hubs, you have 7, and you could think of even more if you really start looking. But why are there so many different choices? It's all about choosing the right tool for the job. There are different type of messages, different type of scenarios. And each of these services handles a different scenario. You could use one service for everything, if you try to, but you shouldn't. You should always make sure you use the right services for what you are trying to accomplish. And if we look at the different type of messages, there are very many different types that you have here. I'm not going to discuss all of these, but I will take out a few of them. For example, if we look at commands. Commands are really about a system telling another system, go do something for me. I want you to place an order for me. Create an invoice for me. Do something that I'm telling you to. Most of the time, the systems will know, okay, this is the next system in line. I'm going to call a certain system. So this is really about telling some other system, I want you to do this for me. Now, if you look on the other side of the spectrum, for example, we have notifications. And notifications are more about, hey, I did something. This is what happened. I'm not completely sure who's interested in this. I will just throw this out there. And if anyone wants to do something with this, here's your notification. As you can see, these are 2 very different types of messaging. And we can basically separate this in intents, which is about, okay, do this for me. Go and do something that I want, and maybe I want to have a result of this. Maybe I just want to hand something over. But I do know as System A that I want System B to do something for me. So those are the intents, while facts are about, hey, this is what happened. So a notification, a report, something like that, a measurement, like, okay, this is what I measured, or this is what happened, this is state that changed. It's a fact that tells me, okay, this is what happened, and if anyone is interested, here you have the information. And so basically we can divide this into messaging and eventing. Where messaging is really about, okay, go do something for me, and eventing is me telling you, hey, something happened. And if you look at these events, you will see that you also have distinguishment here. First of all, you have discrete events. And we already saw this morning with Sam. where you basically have different events that are independent of each other. So this might be something like, hey, a file was created, or hey, an order was placed. So these don't belong together. They are completely independent from each other. They can work without each other. And they also report some kind of state change. So for example, something was created, something was deleted, something was updated. And you can take an action on this. So if I send out, hey, a file was placed on blob storage, for example, some other system might say, hey, if this is an image file, I want to pick this up and start creating thumbnails for this. So system A doesn't know that system B wants to create thumbnails. It just says, system A just says, hey, something was placed here on blob storage. Whoever is interested, here's the information. And then system B says, okay, I'm interested in this and I want to take some action on this. So these are discrete events. The second type of events are series events. And series events are belonging together. So you have a stream of data. And the stream of data belongs together. They are most of the time time-ordered, so you can see over time what happened to my system, for example. It's partitioned in context. So I have many different systems that are sending in some information. And I can partition them by, for example, machine name or device ID or something like that. So you have some context where you can say, okay, this is my partition key. And they report some type of condition. So, hey, this is what I measured. Or, hey, this is my current state. And you can see this changing over time. And finally, you can analyze these. So you can see, okay, what happened during this time frame? What happened over the last week, last year, whatever you want. So how does this system change? So for example, when you start thinking about logging, you can see, okay, my machine was healthy, then it had some kind of issue, it became healthy again. Or maybe some measurement from your temperature, you can see, okay, how was the temperature in this room, things like that. So that's series-based events. So to recap, messaging is really about, I have different systems, they know about each other. They know, okay, if I first have system A, I want system B to do something, then I maybe want system C to do something, and finally the result will be sent back to system A so it can then do its other actions. Whereas eventing is really about, okay, I've got something happened, I will throw it out there and someone might be interested in this. Or maybe no one is interested in this, that's fine as well. I will just throw it out and whoever is interested can pick this up. So let's have a look at these different services. The 5 that I just mentioned in the beginning. And what I'm going to do is for each service, tell, okay, what is this for kind of service? What are its characteristics? And finally, what are the scenarios you would be solving with this? So first off, storage queues. And storage queues are really simple queues. And a queue, you place something into the queue, you have one or multiple senders, and someone else gets out of the queue where you have one or multiple receivers. And each message is only being picked up by one receiver. And storage queues are really about task queues, so small tasks. So for example, I want to start some tasks on functions, VMs, APIs or something. And I have some sender that's placing tasks into the queue, like, okay, go do something for me. And I have all these different workers that are picking up these tasks and start doing the tasks that I need to do. This is where storage queues is ideal for. It's very lightweight, you can just store a lot of messages in there, it's very cheap, and this way you can very easily distribute work over different workers. It's very low cost, so you can put in millions of messages in this for a few cents or a few euros. It's pay as you go, so you only pay for what you use, which of course I really like. So if you put in 10 messages, you only pay for those 10 messages, in which case you wouldn't pay anything. If you put in 10 million messages, you will only pay for those messages, and the higher you go, the more you pay. But if you don't put in anything in there, you won't pay anything as well. And it's very easy to use. And that's the major upside from storage queues. It's just so easy to get you to start using. You just send a message in, you pull a message out, and that's all you have to do. And so thinking about is low cost, it's pay as you go. Often what you will see is that you have different queues for different types of messages. Because that makes it very easy for your workers to know what they are getting. Because they don't have to think about anymore, okay, is this maybe an order or an invoice or a quote or whatever it is. No, you just have one order queue. and everything in there is in order, or is a specific task that you're willing to process. And you can have an unlimited number of queues. So there's no need to have one queue for different types of messages, because you can just create new queues, as many as you want. And you can also have unlimited number of connections. So both for senders and receivers, you can have as many connections as you want. And this is very useful for load balancing, of course. Because now you can have different senders and different receivers, and it will automatically load balance. If you have a lot of senders, but only a few receivers, they will just pick it out in their own pace and just process these. Now, the maximum queue size is 500 terabytes. I would say if you have a queue that has 500 terabytes in it, you are doing something wrong. Please never use this as a storage place. It's a queue. You can put something in, it gets pulled out again. But if you wanted, you could in theory do this. Now, it would take a lot of messages to come to 500 terabytes, because the message size is 64K at most. So think about this. We haven't had any problems with this, because it's something that you take into your design. Then it's no problem. If you have larger messages, you probably use some kind of claim check pattern, where you have just a reference to maybe a file or something, and then it works just fine. But it is something you have to think about beforehand. Finally, there's also a trade-off, because very easy to use, very cheap, but it does only have a few features. So what don't you get? You won't get any headers or metadata. So you cannot say, okay, this message is, for example, an order or something like that. You can just work with what's in the message itself. You cannot decorate anything around it. You cannot do publish subscribe, so there's no routing or anything like that. It's just you put something in and someone else pulls it out. That's all you can do. You cannot set any time to live, so you cannot say, okay, after 5 seconds this should be deleted. You can do no scheduling. There's no dead letter queue. This is also important. So if something goes wrong, you have to handle it yourself. You cannot expect the system to handle this for you. You can only pick up to 32 messages, so no large batches. If you send in duplications, you will have to handle this yourself, so your receivers have to be idempotent. So make sure that you think about this as well. You can store up to 7 days retention, and you cannot do any transactions. So again, you have to make sure you handle this yourself. So where does it fit in? It's really a simple queue. Like I said, it's really just put something in, get something out. Maybe not your most valuable messages, which we'll get to a bit later, but just simple queue. I have some tasks that I want to distribute over different workers, something like that. So the sender sends in the message, the queue immediately sends back an acknowledgement once it's received. So now the sender knows, okay, it's in the queue, I can now trust that this will be handled. And then the receiver pulls it out. This is important to know. The receiver pulls it out, so the receiver manage how fast they are processing. And they also immediately send back an acknowledgement. So as soon as they pull it out, they will immediately acknowledge it, and then the queue knows, okay, this message is now gone. The receiver is now responsible for this message. So that's perfectly fine, but what if you have high valuable messages? What if your message actually represents an order of $1 million? Something like that. You might want to have some more features around this to make sure that you can have some more control over your messages. Know that if something goes wrong, it will be handled nicely and without having to trust the receiver, things like that. And this is where Service Bus comes in. More those enterprise messaging scenarios, where your messages have higher value. And Service Bus is really messaging as enterprise messaging as service. So they take a lot out of your hands, and they will take care of your messages and make sure they are being treated well. It provides queues and topics, where queues, same concept, you put something in, you get something out. And whereas topics are more about publish subscribe. So I have some sender or multiple senders putting something in, and I have subscriptions where I can say, okay, system A is interested in orders, system B is interested in invoices, system C is interested in quotes, but only if they are above $1 million. So now we can do some routing as well. So now we start more coming into a middleware type of solution. and provides reliable asynchronous communication. So what does this mean? It's asynchronous, so it decouples one system from your other system, and it makes this in a reliable way, so your messaging platform will make sure your messages are always handled or are nicely disposed of. Here you can put headers on there, so you can add some metadata, like, okay, this is coming from system A, it's an order, this is the value that's in there, things like that. And so now you can decorate your messages with information that you cannot get from the message itself. Also, these headers are used for routing. So these headers is actually what you will be doing the routing on, which you will see more about later. And so this routing means that you can have different messages going to different subscribers. So you have one message coming in and can go to one or multiple subscribers, which are different systems again. And you can do this with filters, where you can say, okay, system A is only interested in this type of message, and system B is interested in another message, or maybe another value, or something like that. And Service Bus does provide a lot of features. So unlike storage queues, which are really lightweight, really easy to use, really with very few features, Service Bus costs a bit more. It has a bit more of things that you can set up, but it has a lot more features as well. So first feature I want to talk about is scheduled delivery. And scheduled delivery means that I can send in a message and tell this message, you are only supposed to show yourself at this time. So I can now say, okay, I'm going to send this in, but only in 5 minutes, this message will actually show up. So I can now use this as a scheduler. I can say I want to do some task, but at a certain time, or after a certain period of time. So this is very useful when you have to set some delays. On the other hand, you can also set a time to live, which means if this message is not processed, is not received from the queue at a certain time, delete it. For example, stock exchange uses this a lot. Because at the stock exchange, if it's not handled within X amount of milliseconds, the stocks have changed and they don't want to buy or sell anymore because they now have a new price. But this is also very useful. For it too, we use a lot in migration scenarios. So we have a lot of customers that are migrating their things around, where they're currently placing something on a queue, but now they want to start using a topic, for example. But they cannot change the sending system. So this sending system, they don't want to touch. Probably it's at some partner or someone else, and they don't want them to bother with this. So what they will do is forward this message to a topic. And this is just setting on the queue itself. So it's very easy to set this up without having any changes on your sender. And now it will forward this to another topic or to another queue. And now you can start processing it there. And now when you send from queue to a topic, now all of a sudden you can start doing some routing and things like that. You can defer messages, which is similar to scheduled delivery, but now it will actually be the receiver that's picking up a message, saying, okay, I know I can do something with this message at some point in time, but not now. I will place it back on the queue and defer it for example, 5 or 10 minutes. And after 5 or 10 minutes, it will then become visible again. Someone will again pick it up, and hopefully whatever you were waiting for has now happened. So maybe you first need to have a quote before you can send an approval. If I already received the approval because they were both sent at the same time and with timing issues on network or something, I can now say, okay, put it back and I will process it later. You can use sessions. And myself, coming from a BizTalk background, I love convoys. I don't love BizTalk, I love convoys. I see you smiling there. No, but I love convoys because convoys allow me to do in-order processing. And sessions allow just this. So if you put a session ID on your messages, now you can have a flow of messages. For example, if I have an order, first I have to process the order, then I have to process the invoice, and then I have to process delivery. If these come in at the same time, at almost same time, and I have different receivers, and I don't put a session ID on them, each of these messages will be picked up and will be processed, and might be processed out of sync. So what I can do is put on the session ID, and now my receiver will know, okay, if I have a message that has the same message ID, I first have to do this first message, handle this, and only then can I get the second message for this session ID. Now, if the session ID, for example, is an order ID, I can still process the different orders parallel, but messages for the same order are processed sequentially. This is very powerful as well. I can also do batches. So I can actually send out batches or get in batches, which is very nice if you are working on more restricted lines. I can actually auto-delete queues. So I can have my system create its own queue and say, okay, once this queue has not been used anymore for X amount of time, for example, for more than a day, it will auto-delete this queue. So you can just have your receivers build their own queues, receive some messages, and then delete them again as they are not used anymore. You have some form of event type eventing that you can do. You have an on-message handler, which if you are working with .NET SDK, basically means you will get a notification, hey, there's a message for you. This does still use polling underwater, so it's not really eventing. We will see more on that later. But it does give you in your own applications, you can do some kind of event-driven development. Here you can actually do detection on duplicates. So you can say, okay, if the same message with the same print comes in within, for example, 5 seconds, delete one of these messages. And you can specify if they have to delete the first message or the last message that came in. You can add actions in your queues and topics. So you can actually say, okay, if a message comes in, for example, add a header on it. So I might say, okay, when it comes into this queue, add a header on it with now saying this is this type of message, and then forward to another topic, and now you can do routing on that header that you just added. Once again, we use this a lot in migration scenarios. You can do transactions. So you have the concept of peak lock. And what you will do is say to the service bus, I'm going to peek a message and I'm going to place a lock on this. I'm then going to try and process this. If I succeed in processing, I will complete it. If I don't succeed, or if something happens to my processing unit, it will then be either abandoned or it will time out and the lock will be released and it will be picked up again by the next receiver. And finally, I have poison message handling, which means when a message cannot be processed. So, for example, like I just said, if I abandon it 10 times, by default it's 10 times, you can adjust it yourself as well, but by default it's 10 times, it will then be a poison message. So service bus now knows, hey, this won't be handled because it's already failed so many times. I will now send this to a dead letter queue, and then I can have another system that's listening on this dead letter queue and will notify me, hey, something is going wrong in our system. There are messages that could not be processed. And this might indicate something bad with your message itself, or it might indicate something wrong with your infrastructure or your systems around it. So service bus comes in 3 different tiers. So you have a basic tier, where you just have queues. You have your standard tier, which has queues and topics. And you have a premium tier. And the premium tier has some other capabilities as well. Now, the premium tier is quite a bit more expensive than the other tiers. So I think the basic tier is like a few euros per month. Then your standard tier is like 40 euros per month. And premium is like 600 euros per month. So it's quite a bit more expensive. But I think if you are working with enterprise messaging, where your messages are actually representing value, you should be on the premium tier. First off, because you get dedicated resources. So this means that your messages will always be processed in a predictable manner. For example, let's say Facebook decides to also start using Service Bus and they start putting 10 million messages at once on the same infrastructure that you're running your messages on. All of a sudden, it might be that your messages take a lot longer to process. This might start to hinder your processes. So this is one reason why you should be using Premium for the dedicated resources. Another one is GODR. So if you are using Premium, you can actually say, I want to replicate my infrastructure, so my queues and my topics, to another region. This is only for the infrastructure at this moment. I think they are working also on the data, but it's not there yet. So for now, if there are messages in there, they will be lost. But like I said, I think this will be coming at some point as well, that also your messages will also be replicated. You can use availability zones. So you can actually have different zones, and one zone goes down, you can switch to another zone. For now, you have to do the switch yourself, because Microsoft says we cannot currently say, okay, when should we switch? So you have to do the switch yourself, but you can then, it's very simple. They provide all the tools and basically 3 lines of codes to set this up. So it's very easy to set up now. And finally, and this is a very important one for most of our clients, is virtual network integration. So let me tell you a little story about the Goudse. And the Goudse is one of the clients that I'm working with. They are an insurance company. And so they have a lot of valuable messages. Those messages they are sending over the line can contain policies for up to 10 million euros in one message. So they need a good decoupled system with very high availability, with all those capabilities that we saw that Service Bus provides us. But what they said is these messages are so sensitive because there's a lot of GDPR data in there, PII data, financial data. We don't want this go over the public internet. So we want everything in an internal network. So what they said is, okay, this is one of the reasons they chose for Azure. Because with Azure, with the virtual network support that many of the Azure services have, they can now create a private network within their Azure resources. They can pair this to their own on-premise network. They can pair this with their partners. And basically they now have a big network, all within the first network, completely private, completely isolated, and still have all those capabilities that Azure provides. Where Service Bus is a very important one for them, because everything has to be decoupled. These are high valuable messages. And thanks to this integration, they can now use Azure for all their policies, which they have to send around between partners, between other insurance companies, and things like that. So let's have a quick look at topics and subscriptions, because I think this is very nice. I hardly ever use queues these days. I will almost always just put in a topic, because you never know if you are going to get a different subscriber that also wants those messages. At point A in time, when you start, it might be, yeah, we just have one receiver. Almost always I've seen at some point you will have another system that also wants these messages. And it's only a very small overhead that you get for using a topic instead of a queue. And basically what you have is your sender that's sending in these different messages. And in this case, these are orders and quotes. And these orders and quotes need to go to different subscribers. And these receivers, so the sender only knows about the topic. The sender does not know about who's going to get these messages. On the other hand, the receivers only know about their subscription. They don't know who's sending in these messages. So they are completely decoupled from each other. And using these filters, so in this type is order or type is quote, Service Bus knows, okay, this message needs to go to this receiver. So it will look into the message, it will look at those headers, it will find the type in the headers, and it will then route it to the correct subscribers. And these subscribers can be multiple subscribers or multiple receivers on one subscription. So I can still do load balancing, can still do all the nice stuff, but I can now do it in a publish and subscribe manner. So where does Service Bus fit into the big picture? First of all, when you want to decouple your systems. And this is, I think, is just a very good architectural pattern. Always decouple your systems. Don't start building spaghetti architectures. I come from a business background. I've seen too many companies where basically every system was talking to every other system in there. And it was just such a mess that you could not know anymore which message was going where. So put something like Service Bus in between to start decoupling that, have messages sent in, and have Service Bus relay those messages to the right systems, like an ESB pattern type of thing. Service Bus also is very good when you have that transactional consistency that you need. So if you want to have those messages, if you want to start processing them and only complete them once they're done, this is where Service Bus really shines. Because if you cannot complete this message, or if your receiver goes down for some reason, the message will just will stay on the queue. The lock will be released at some point, and then another service can try it. If that also doesn't work for X amount of times, for example, by default 10 times, it will place in a deleted queue. It's still there, it's still safe, you are not losing anything. And like I said, these are high valuable messages. You don't want to lose these messages, you want to make sure they are always there and can be handled. Another scenario is where you want to do retries. So also consistent with this, if you know that your receivers are not very stable, You might want to say, okay, we're going to put service bus in between, because now we know that due to this peak lock system, if one of my receivers goes down, it will still be picked up, and the next one will still handle this. You can also use this for throttling. So another scenario where we use this at Vodafone. So Vodafone, the big the mobile company. So we were building a web shop for Vodafone with all the latest techniques. We were using Azure, we were building a nice front end. And basically what we were doing was saying, okay, we need to handle an iPhone launch or Black Friday or something like that, where you get a lot of messages in a small amount of time. Now the problem was their backend, the Vodafone backend, that actually gave out the subscriptions, so give you a mobile phone number, things like that. They were not the best system, so to say. If they received, if that system received more than, I think it was 20 messages per second, the whole system would start rebooting. Which is not ideal on a Black Friday, as you can imagine. So what we did was place Service Bus in between. Service Bus now was picking up all these messages, so the front end could just get all these orders in, it would create messages for them, put them on Service Bus. They are now stable, they are now secure, and we have one service that just picks up a few messages each time, handles them in the back end, creates phone numbers, creates subscriptions, and then gets the next batch of 5, and now another batch of 5. And now everything kept working, no more servers that were shutting down, no more big crashes. So Vodafone was very happy, and we were happy as well, because now our front end could actually work. And finally, Service Bus is really nice if you want to implement a circuit breaker pattern. And for those who don't know what a circuit breaker pattern is basically saying, if my backend has too many issues, don't just keep putting them back on Service Bus and keep building up a bigger log and a bigger log and doing more and more retries, where at some point you will just be doing so many retries that you're just slowing so far down that you cannot handle anything new. Instead, say to your backend, okay, if you have too many failures, stop processing, wait for things to go back to normal, and then start processing again. And by using Service Bus, you have this durable storage, so your front end, your sending messages, your sending systems can still keep sending messages in. And once your backend is back up again, it will start processing them. So next, Event Grid. We already saw a bit about this morning, but I will go into some points here as well. An Event Grid is really about eventing and about discrete events. So, quick recap from what you just saw. So an event, it's something happened. This is what happened. If someone is interested, here it is. And triggers a reaction. And this is about discrete events. So these are the events saying, okay, a file was created, an order was placed. And it's based on facts. So it's not saying, I want you to try this. No, this is saying, this happened, this is not going to change anymore. This is the data around this. And it can be serious or discrete, but we are going to talk about discrete for Event Grid. So Event Grid, we also already saw this picture, but just to show you again, there's a lot of different services. I think there's already a couple more than I have here, but there's a lot of different services in the Azure Event Grid that can create events. And there's a lot of different services that can receive these events and handle them. And Event Grid is really engineered for cloud-based computing. It's really based for the cloud. It's very highly scalable. 10 million messages per second. That's a lot. I don't know many systems that can handle 10 million messages per second. It's also very durable. It has standard retry intervals that are going up and up to 24 hours between retries. By default, it does deliver 30 delivery attempts in 24 hours. This also, of course, is completely customizable. You can set up your own retry intervals. You can set up your own schedule. And if it cannot be handled within those retries, it will be the dead letters as well. Only unlike Service Bus, where dead letter is actually just another queue, for Event Grid, it's a storage account. Same principles other than that. So it will be placed on a storage account. You can have another Event Grid going off on that, saying, hey, something came into my dead letter storage account, and I'm going to start maybe some ticketing process to have my engineers look into what's happening here. So the concepts around Event Grid is where you have events telling me, hey, something happened. Here's some information around what happened. I've got my publishers, that are the systems that are sending out events. So storage accounts, IoT hub, resource groups. I can also create my own. I can create custom event publishers. I've got my topics, and this is where I send this in. Similar to a service bus topic, but in this case for Event Grid. I've also got subscriptions. Once again, I can set some filters. I can do routing here. I've got my handlers. So this is going to pick up those messages. So for example, a function or a logic app. And these are the messages that we are talking about. So this is an event for a storage account. And there's two parts that you have to distinguish here. You've got your header saying, okay, what's my topic, which in this case is storage account. It will tell me which storage account through this event. There's a subject, so telling me about, okay, for a storage account, it will tell me, okay, this was the message that triggered this. And you got an event type saying, okay, this is what happened. And of course, this context, the values of these will be different for different services. But these fields always need to be there in your header. Next part is the data part. And this is, the data part always has to be there, but what in the data part is completely up to the service that's sending out the event. So in this case, it will be something about, okay, I got to put blob API, I've got a certain client, blob type. So this is all about by blob. For the resource group, this might be something, okay, this was my resource group, this was what was created, something like that. And this can be completely different for every service. Just make sure that you know that the header is always the same, the data can be different. And you can also create your own events. So you can create custom events. So you can have your own event type in there, your own topic. Still, beware that if you are using event grid messages, you have that schema that you have to adhere to. Although, you can also create your own schema. And this is only useful in a couple of scenarios. I haven't actually used it myself, because normally when you are starting to do eventing, you are working with systems that you are, or have some influence over. But it might be that you have one system that you cannot change and you still want to have those events. Then you can create your own custom event type as well and use that. And what we will do here is, once again, we can create subscriptions, just as with Service Bus, where we can say, I'm going to do some filtering on those three top-level header fields, my topic, subject, event type. So these you can very easily use for routing. However, you can also have some advanced filters. And advanced filters actually work on the data of your content. So the data part of your message. And this is very valuable. You cannot do this with Service Bus, by the way. Which is also one of the reasons I also like to use Event Grid for eventing. More on that on, I think, the next slide. But you can also work on data part. And supports up to 10 levels of nesting. So if you have a JSON document, you can go 10 levels deep. That's quite far that you can go for your whole filtering there. And you can actually combine multiple values. So you can use OR and AND languages, where you can combine different filters to create a big filter to say, okay, there's a very specific message type that I'm interested in. Maybe only from a certain client with a certain value for a certain destination, things like that. And so these are the types of filters that you can currently use. So you got your numbers like less than, greater than, things like that. You got your strings. This one I use a lot. So for example, for another client of mine, Boskalis, we actually use so what they do on their ships. So they have big ships and they have a lot of materials that they have to order. And we actually use the GPS position. We will get out of the GPS position, or not the GPS position itself. The GPS position will be calculated to a certain region. And that region is sent in this event. And depending on the region, we'll actually send it to a certain system. And Boskalis has at the moment, I think, seven ERP systems. So depending on the region, it has to go to a certain ERP system because they have to order it at a certain country, at a certain location, which uses that ERP system. And using Event Grid, we can now very easily specify, okay, this message needs to go to that ERP system. Without having to build anything with logic apps or things like that, only just one filter on Event Grid. So for Boskalis, this is a very nice part. And Azure was actually one of the first that also introduced cloud event support. And cloud events are standard that's being built by Alibaba, Azure, and there's now also a couple of other companies. You might have heard of them, Google, SAP, Oracle. They are now all working together to create a standard for cloud events. And basically this is just an envelope saying, okay, if you want to send messages between clouds, this is what should be in there. And it looks a lot like what we just saw. You have some event type, some path, things like that. And what you now can do is actually send, for example, a message from when a blob was created on S3 storage. Send this event to Azure Event Grid, which will then trigger a function, which can then receive it from your S3 storage. This is actually one scenario that we use at one of our clients as well. They have everything in Azure except for their storage because they already had this in S3 and they are using some tier where it's much cheaper for them to keep using that. But they do want the whole processing in Azure. So they are now using these cloud events to actually do this. So why do we use Event Grid, or where should we use this? First of all, serverless applications. And this is where I use it most. Like I said, Event Grid can do up to 10 million messages per second. So we will never do this on the outside to our SAP systems or to our ERP systems or anything like that. Because if you send 10 million messages to, for example, CRM will just give up and go blow out. So what you want is to have service applications that can scale up very fast, like functions, logic apps, and also scale down again. And in that case, it really helps both for eventing, but also for messaging. Like I said, at Pascal, we also use messages, where you actually have the message just in the data portion. What you can also use it for is for operations. And see this as Azure Policies ++. So you can do a lot with Azure Policies. You can set some tags, things like that. But maybe you want to do some additional things. Maybe you have a CCDB store or something like that, where you want to have all different type of messages registered or your devices registered or something like that, where you can now say, okay, I want to do some calculations, apply a certain policy, set this into a certain database, things like that. Where with policies you can do some things, like you can add a tag, but it's very simple that you can do like, okay, just use these default tags. If you would use Event Grid, for example with the logic app, you can actually start pulling in, okay, which region was this created, who created this, things like that. So you can do a lot more advanced stuff. And finally, third-party integration. I already mentioned it. You can also use your own custom topics, custom events, custom subscribers. So you can actually do all of this just with Event Grid in between, and just you have custom applications on the outsides. Or have maybe custom application as your sender and a function as your handler. So this allows you to bring every component in there. And of course, this was first built with Azure itself in mind, but you can actually do a lot of this also in your own applications now. Next up is event hubs. And this is really about those series events. So that stream of events that we are getting. And it's kind of like, this is a sample from Denver's Nova, and I always liked that example because it's very easy to understand. It's like a tape drive. I think most of us here know what a tape drive is, where you can record some data. In the tape drive it will be music. In our case, it's a stream of data, so a stream of messages coming in. And it will just move forward. So it will just be appending new messages. You cannot say, I've got this message that has to go in between here. You cannot do that. It will also just be putting messages into the stream coming in. But you can actually go back and forward on the stream. So you can actually say, and think event sourcing here, you can say, go back to the beginning of the stream, so go back to the beginning of my messages, and replay all my messages. So I can now do event sourcing on top of this. And I can say, okay, I want to go completely to the beginning, or maybe I just want to go back 100 messages, or 200 messages, or whatever. Because for some reason, one of my processors died down, I just need to process a few messages here. So I can go back and forward, and then start reading from that point in time. And you actually have different channels, where you can have different data in different channels. And for event hubs, we call these channels, we call them partitions. So what happens is you have a lot of senders, a lot of event producers. This might be something like an IoT devices. If you don't need all the features that IoT Hub provides, you just need the messages, you could use event hubs for that. But also, for example, if you have logging data, maybe from your virtual machines or something like that. And they will just be sending all this data in. Can use AMQP, HTTP, Kafka protocol, more on that last one later. So they will be sending this in, and then it will be distributed over these different partitions. And if you don't specify a partition key, it will just be relatively evenly distributed over different partitions. Now, if you do specify a partition key on your data, and this might, for example, be this is my device ID or my virtual machine name, it will then make sure that the messages for the same ID are placed in the same partition. And this keeps the data together, and you can play it in the sequence it was received in. And then your receivers. And you can have as many receivers, maximum as many as receivers as you have partitions. You can have at most one receive per partition, but one receiver can have multiple partitions. So in this case, each receiver would get one partition. If you only had two receivers, each would get two partitions, etc. And receivers listen on a consumer group. And the consumer group basically gets a copy of each message that's coming into those partitions. And then each receiver will get the messages for their partitions. Now, if I say I have another application that's interested in these messages, I can create another consumer group with its own receivers. And now each of these consumer groups will get a copy of each message. So if I have two consumer groups, each message will be sent to each of the consumer groups. What's more, each of these receivers has their own partition and can go back and forth on their own partition as they want. They are completely independent from each other. For those that know Kafka, will probably recognize a lot of this. So who here is using Kafka? Few people. So this will be very familiar to you. And so it does look a lot like Kafka. They are both partition consumers. So you both have those different consumers with the partitions. The partitions are independent of each other. So you can say, okay, on this partition I want to go back. On this partition I just keep reading. They both have the client side. So the receiver is saying where he is in the stream. So the receiver can say, I want to go back, I want to go forward. It's not the service that tells them there's a new message. They can scale very high. And so they actually are kind of the same, with a few differences, but in concept they are very much the same. And that's what Microsoft decided to start building Azure Event Hubs for Apache Kafka. And basically what this is, it's a Kafka compatible endpoint. So it's not Kafka in Azure, it's just a compatible endpoint. But you can actually use your existing Kafka tooling, your existing Kafka stream, and just point to your Event Hubs endpoint. And it's actually just as easy as just changing connection string. So you have your Kafka application, just change the connection string, and it will just start working. You will now be receiving your messages in Event Hubs. And why do you want this? Mostly because Kafka does not yet have a PaaS service. They have some managed IaaS that you can get, but don't have PaaS like Event Hubs is, where you just say, just do everything for me, and I just want my messages in there. And that's the big upside of Event Hubs. And by combining these two, you basically get the best of two worlds. Now, it is important to note, they don't support everything. So if you have large messages, it's not supported. There's some other things around tooling. They have a lot of tools are supported, but not everything. I'm not a Kafka user myself, so I cannot exactly say which tools are there and how you can use them or not. But if you just say, okay, I just got my default messages and I just want to have a nice PaaS managed service to process these, this is a very nice example. Or a very nice tool for that. Another thing that Microsoft saw is, okay, we have these messages coming in. And basically, every time that someone puts up an event hub, they have two streams. A fast stream, which is basically going to Stream Analytics, streaming to Power BI, doing some queries on that. And also, I think it was 90% of the customers also had a slow stream, where they would be writing it to a blob storage or something like that. Now, what Microsoft said is, if that many people are doing this, maybe we should create something for this. And that became Event Hubs Capture. And basically what it does, it provides you with a checkbox. You just click a checkbox. You have two sliders where you say, okay, this is the amount of time, this is the amount of the size of the messages. After which you have to capture this and make a file out of this. It does this in the AVRO format, which is a binary format, very good for high density compression. And this is the most important part. It doesn't impact your throughput, because this is why Microsoft did it. If you are working with millions of messages per second, there are not many people who can set this up correctly. Because there's just so much that you have to think about. And Microsoft, of course, has the people, they know the service, they know everything about. They have built Azure. They know a little bit about high volume messaging processing. So they said, we have seen too many times where the whole stream would slow down because of the slow capture or the slow stream. We are going to introduce capture so everyone has this nice thing that they want without any impact on their fast stream. So how does this work? We set a certain window, so we set two windows basically. So we set the size and the time frame, and whichever comes first. So if my message is either already 20 megabytes or 5 minutes have passed, it will create a new file and start the next one. And it will keep doing this forever and ever. And you will have all these nice Avro files that you now can use in your other applications. So where does it fit in? We have our event producers. And like I said, this might be some devices. They might be virtual machines. Something else that's creating logging. It's being collected. So it can do this with IoT, well, with an edge device, not IoT Edge, because then you will go to IoT Hub, but you can use this in a cloud gateway or field gateway. And finally, Event Hubs will be capturing all this data and will be streaming it in. Then we have our different processing, so our fast processing and our slow processing. We will do some storage, which might be shorter term storage, like we will put it up on a service bus, or long-term storage, where we put it into a data lake or something like that. And in the end, of course, we like data, we like to read in tables and things like that. Most of our business users don't like the data in that format for some reason. So you will make some nice presentation on top of this, maybe using Power BI or Power Query in Excel or something like that. So final one. And this is a bit of different type of service. So far we have continuously been talking about queues or topics, which are also kind of queues. This is a completely different type of messaging. It is still messaging though, so it's important to know about this one as well. And it's relay, so WCF relay and hybrid connections. And together they are called relay. And basically what this does is you can create a hybrid connection between on-premise and the cloud. So like I said, hybrid connections, which is more your HTTP protocol, WCF relay. I think the name kind of gives it away, does WCF. And so it allows you to connect your on-premise services to the through the cloud, so you can expose it to the cloud very easily and very securely. You can very easily do load balancing, so you just install multiple agents on-premise, and it will automatically load balance over those using round-robin method. And so you can have your internal services. You will create an external endpoint for it without needing any network changes. You just need an outgoing connection. And this is why this is so important, so powerful. You don't need to put any incoming ports open for this. So for those who know how hard it can be to get a port open because you are opening up an attack surface, you don't have this with this anymore. I will show in a picture later on how this works, but that's the powerful thing of this. So here we go. What we do is our service creates a connection to Azure. And it will then create this control channel, which is basically a return channel that goes back inside. So our outgoing connection is open, and we use the return channel to go talk back out inside to our service. The client that's calling us will then call the endpoint in Azure, and then network magic happens. I could explain this. I would need another hour or so. But basically what happens is your client sends message. The message goes in through the control channel to the service. The service then receives, okay, I've got someone that wants to connect with me. It will go out to this endpoint here, and they will meet up here. Like I said, there's a whole white paper on this. There's several sessions if you want to know more about this. This is a very good starting point, which explains the protocol. It's about half an hour just to read this one article. So, like I said, it's network magic. There's a lot of things going on here that basically, like I said, I can talk another 2 hours on this, which I'm not going to do. But it's very interesting and very powerful if you want to expose those on-premise services. So why would you use this service? First off, if you only have maybe 1 or 2 servers that are remaining on premises, but that you cannot really move up to the cloud, or not yet, but you still want to expose via the cloud because you don't want that to expose your internal network, and you cannot really use a VPN or express route or things like that. It's maybe too costly or just maybe too complex. Same for VNet. It might also not be possible because of cost or because of other things. Or another one that we see quite a bit is if you have to keep the data where it is. We all have that one client, or we all have that one database somewhere that you cannot put into the cloud because it's your HR data or something, and they don't want that to go up into the cloud. But you still want to expose it to some users, some partners. So in this case, you can also use this relay or hybrid connections to expose this service. Your data is still on-premise, your service is still on-premise, it's not leaving, it's in your control. You can very easily just shut this down without any problems. It's under your control, but it's still exposed via the public cloud. So with that, we're almost done. A few takeaways. Don't try to read everything that's on here. I will be sharing the slides. But this is basically just an overview. Okay, what do you care about? What do you care less about? What is your focus point with the different services? But basically what it comes down to, if you're doing serverless, use storage queues for low priority messages, low value messages. Use event grid for higher priority, or if you want to do routing. If you're talking about streaming data, use event hubs. So you have that stream of data with logging, devices, things like that. Event hubs is your go-to service. If you're talking about high valuable messages, enterprise messaging, you need those extra capabilities. Go to Service Bus. And finally, if you need a hybrid connection, if you have that one of a few servers on premises that you want to expose, but you cannot do this via VPN or something like that, have a look at your relay and hybrid connections. So with that, I would like to say thank you. Here's my contact information. Please reach out to me on Twitter if you have any questions, or come up to me after the session, or come up to me tonight during the party. I will be here tomorrow as well. If you want to read more about this, I have some blog posts around everything I told here today. The slides are already up on GitHub. I will be sending the link out on Twitter as well. And this last one is a very nice one as well. It's by Clemens Fasters, which is basically the king of messaging in Microsoft. Where he also talks about why should you be using service messages. So he goes into some more details as well than I did today. So if you have more questions, come up to me, start reading here, or just ask one of the other speakers here as well, because everyone here has a lot of knowledge about these kind of things, and everyone here is willing to talk. We don't bite, except for Rick, of course, but... So thank you, and enjoy the panel, and afterwards the party.
Thank you, Eldert. All right, so we're going to have the panel after this. And for those of you who have to leave at 4, the panel questions, we are going to speak about Kubernetes and PaaS, some serverless, some community stuff maybe some compete like AWS and Google, and then modernizing or cloudifying apps. So we have questions related to those. If you have any questions you want to ask the panel, feel free to think of those now. But for the next 15 minutes, we'll have a break, and the panel starts here, 15 past 4. So you can fetch coffee or whatever, and then we have a chat. Cool.
Thank you.